doesn't matter a ton.
Yeah, I'm not gonna attempt cameras because if I remember right, when we tried that on this computer last time, it just caused difficulties.
Yeah, for sure. Actually, in that case, I will stop uploading because that'll just save.
Yeah, we're
Uh,
more likely to not have internet troubles if we do that, probably.
right. Yep. Cool.
Yeah, looks like we're good. Welcome to the stream. And then I'm gonna say live now, live now. And then we should pop this into the Holochain chat.
Mm-hmm.
I guess just like the which room?
I think H app casts is a good one because it's all about casting this stuff.
Oh, okay, cool, sure.
I think that's what it's about.
Yeah, well, I mean, there are 1,000 people in the app dev chat, and there's 15 in the H app cast. So.
Yeah, I think app dev is a good place to put it too.
Yeah, I think I'll definitely do it in there.
I think app casts are going to be people who are much more active.
Yeah, probably.
And knowledgeable. Although they're probably an app dev too.
Yeah, but I'll put it in app dev. I feel a little bit weird about putting it in 2 different channels.
Yeah, for sure.
I feel spammy.
Yeah, well, spammy.
Yeah. Revial, who is Jacob?
Yeah, I think so. Yep.
He said that he might have a 1 hour delay on the road.
Yeah, I saw that.
He may be able to join later. I don't know if we should necessarily plan on that, but I said that if he does,
right. Yeah, I think we go through stuff, and we should give him the Hangout link.
Yes, that's a good idea.
In the direct message now, and just like he can join and jump in whenever.
Yeah. Okay, I'm gonna message him now. Hey,
cool.
Do you know how to spell his name? Jakob. Yeah, okay. Yeah, it's just above in the chat here.
And yeah, it's also in his. If you click his name, it'll come up.
Okay, cool. All right. Yeah. Okay, cool. I think we are good to begin.
Cool.
Let's switch to this, and then see if we can get the GitHub up here. Which would be.
All right.
No, not that. Wait, what is that showing? Okay, 1 second.
Sure thing.
No
problem.
Yeah, I mean, you can start talking about it if you'd like.
Okay. Yeah, I'll just get started on kind of what the plan is for the day. We're gonna go through a repo that I created as just the very first attempt prototyping a set match games kind of back end. I don't know if it's a back end. I don't know what it is, but it's the part of it that's like Steam. And I built it on Holochain, the alpha, the version 004 alpha release. And it's really just kind of getting that up and running, and just a few entry types set up. The sort of entry types that we've been talking about this whole time, the games, components, formats, and modes. So those, and there's validation for all of those, and we're we're gonna go through that and check the Holochain app guide if we need any clarification on what stuff is doing. So,
Yeah, cool.
cool.
So it should be up on our screen now. I'm
Yep, I see
presenting,
it.
so we can look at the same thing.
Yep.
Yeah. So here we go. Immediately, if anybody was watching the last time or has gone through the beginning of the Holochain guide, this stuff should definitely look pretty familiar.
Yep.
You can see we've got the Zomes folder, this app.json, which probably just has this basic stuff in it.
Yeah, it looks like I didn't touch it at all.
Right. Yeah. This is just generated by the terminal command.
HC create or whatever it is.
So I think we can just jump into the Zomes here.
Yeah. So what I've got here, I've got master, and I've got there's another branch. I forget what I called it.
Generic elements.
Generic elements. Yeah. So I had I ran into a spot, and we can sort of talk about how I got through that. But I think we should go through master first.
Okay.
And then we can look at the generic elements PR, which I think I have a PR open for it. And just to see how I got from one place to another.
Cool. Okay, sounds good. All right, so we'll jump into Zomes here. I assume you didn't do anything in the tests folder.
I did.
Oh, okay. So maybe we should do that after this.
Although maybe not in master. Let's look at tests and see what's in there.
All right. Test.
I'm not sure if it's in master or not.
Yeah, it does look like you did some stuff here.
This might just be.
Oh, maybe not. I saw the JS.
Yeah.
For some reason I thought Jesse.
JS test scaffold. So yeah, this is like just an initial commit. But let's look at test.js or index.js. Yeah, this is all just straight example from the creating the app with the HC command.
Cool. Okay, so let's look at the Zome here.
The Zome. Yep.
So there's one Zome right now, and it's elements.
Yep.
As in, the way that we've been talking about elements. If you've been following along, this is a big part of at least our current theory of how the system should work. This file is just a description, so not much to look at there. But so let's check out the code. Again, this stuff is all standard Holochain and Rust stuff. So let's look at the source, and then this is going to be the important stuff in the library file here, the lib.rs. So yeah. So like maybe I can just say to start with, and then you can kind of take it over that. I was looking a little bit at this earlier, and again, a lot of this stuff should be pretty familiar to anybody who's looked through the Holochain guide. So there's a defined Zome macro down here that has all the things that it's supposed to have: entries, genesis, functions, traits, and then all those things are defined here. And so yeah, do you want to go through what you were?
Sure. Yeah. Actually, the way I kind of like to do this. In sort of a code review style is to have someone who didn't write it kind of go through and describe what they see and what they understand, because that helps us not sort of gloss over things that might be confusing or so yeah, go ahead and if you basically if I see something that could use explanation, I'll jump in.
Cool. So the very first line here, I remember seeing this and not knowing what it was then, and we talked about it a little bit, and I think it has something to do with typing, if I remember right.
Yeah.
It looks like
I'm not totally clear on what that is. That's a Rust thing to investigate and learn about, but it's in all of them and it errors without it, so it's there.
Yeah. So this seems to be just a Holochain thing. Not sure exactly what that does, but
and I am using try from in a number of places.
Right. Yeah. It was something we saw showing up, and I think in context it does make sense. But then so this stuff then I understand to just be basically importing some crates, and this is Rust stuff, and this line macro use is what lets you use macros from those imports.
I think so. Yep.
or something like that. Anyway,
Yeah. Yeah.
and so the HDK, this is Holochain Development Kit, I think is what it stands for, and
Hmm.
um, the current implementation of that is in Rust. There could be other ones in the future, but of course we're using the Rust one here, and that's what this is. So that's a bunch of lets us use a bunch of Holochain specific functions that are important. Um, then this one, Serde derive. This has something to do with reading and writing files, if I remember correctly.
The derive part, I think, is gives us access to all of these derive statements, serialize, deserialize, debug, and default JSON.
Right. So it has to do with
And I think
reading JSON.
it has to do with handling JSON. I think Serd or Serde is a JSON handling thing. I didn't look into that much. This is just this sort of was copied from the examples.
Right. And then so then here's another Holochain specific thing. And then a bunch more Holochain specific stuff. And then this is like making it easier for us to use all these functions from HDK.
Yep.
So this is just organizing that stuff a bit. But you can get an idea of some of the. Man, I want to disable this. Can I disable this? Let's just get rid of it for now. Sad to see you go. Leave me alone.
That's fine.
Okay. Yeah. Okay. Perfect. It's not doing that. Not making a pop-up every time I highlight something now.
That's good.
Much nicer. So yeah, those things. Then okay. Now we're getting to some real code.
Yep.
This is a struct, which is a basic structure in Rust, and then this top line means, I think, is like traits for the struct.
I believe so. Yes, I believe so.
But anyway, so
I think
it's somehow
Holochain seems to use serialize, deserialize, debug, and default JSON under the covers when they're for when they're compiling to things. So anything that's going to be an entry or used in an entry, I believe needs those methods. And it makes sense, right? If we're going to put it in our local hash chain, we need to be able to serialize it, turn it into a string, which is and a JSON string.
Right.
And we need to be able to go into that string and then come back out of that string.
Yeah, so maybe one way to think about that would be that since Holochain is eventually turning everything into WebAssembly and JSON files, anything that is
I don't think that's quite where it's going. I think it's the fact that Holochain, the way Holochain handles entries, whether or not they were going to be using WebAssembly or JSON in that area, since what they're doing with the entries is maintaining them in a hash chain so that they can be validated and so that the sort of chain of creation can be validated. That needs to be hashable, which means serialized. And then so we need to be able to get into and out of the whatever format we're using to store that hash chain.
Right. Okay. Well, anyway, so here we have a struct called component type, and it's just a string right now.
Right. Right. So this is a Rust. I think it's called tuple struct or struct tuple or something like that. Basically, what it is I'm using a string for this, but I only want things that I've said are component types elsewhere in the program to be in here. So this is like a constrained string, constrained by the type system. Only strings that are supposed to be represent component types can be this type.
Right. Plus, it has these other things that you've added to it.
Yes.
But so that's relatively straightforward. And then so here we have another struct. This one's for game. It's got the same stuff here. This one's slightly more, got a little bit more going on. So it's got a command. Which is going to be a string.
And this is going to be interesting. And I've got some ideas now about how to actually implement this to make it actually work. Because command, I mean, it will work, but like only if you're on the same kind of system that if it's a Linux command, it'll only work on Linux, right?
Right.
So that's not going to be like long term viable. And I've got some ideas, and we can talk about that later. Um, but I also sort of thinking through this recognized that it would be good for games to sort of state what kinds of components they need. Like Magic needs Magic cards,
Mm-hmm.
um, and Magic can maybe use some other kind of component types. Um, but like some games could have required an optional component type. So this way, a client or some other part of the client that's kind of browsing the system, looking for games and formats to play, can sort of tell whether or not a format is going to work in this game.
Right. So that's what you're describing there is these next two lines.
Yes.
Yeah. And then what
so
is
right, vectors and component types.
Right. So this makes sense. So you've got something called required component types, which is a vector of component types, these things,
Yep.
And then
Yep.
optional component types, which is the same type.
Yep.
For this command,
Yeah.
Can you talk a little bit more about what that is there for?
Sure. Yeah. So the game, we these elements are all metadata about enough metadata to like run a game and validate its result.
Mm-hmm.
And so the command is sort of a hack first attempt at that. I mean, if I had a game that had a command, it could be like curl the installer from this website and install it and then run the game. Right. So it's just a means to get the game going. It could theoretically be just a text description of like how to play the game and how to write down the result in a validated way. But we want it to run. We're eventually definitely going to be wanting this to run smoother than that.
Right.
Which means I think we're going to end up writing game launchers, like game type launchers, like a native Windows game launcher, and write those in Rust, and basically write a launcher type in Rust that the game can reference and say use this launcher type and hand it these parameters and it'll launch my game.
Right. Okay. Cool.
So we'll figure that out, and that'll be probably a big part of a big job in building this system.
Yeah.
But
yeah. Okay, that makes sense though.
Correct.
Okay, so that's our second struct here, and then moving on from there, we've got some functions. So a game entry. This is the stuff that is going to end up in the define zone macro, I think.
Yes.
So, and you can partly tell that because it's going to output a validating entry type, which is the type that the define zone macro needs.
Yep.
And so here's that macro, the entry macro. And so this is for game entries. Entries are what Holochain calls things that an agent might store on their local chain, and then it would get shared out to other people. But anything that's going to get stored on the local chain has to be an entry. And so here we're defining one. It's called game. Has a basic description. Has these public sharing settings. Native type game, which is the thing that we've defined here. The validation package, which is just the standard validation package for entries that Holochain gives you. And then the actual validation, like what it's actually supposed to do when it validates, which includes this validation data thing, which I don't totally remember what that is.
Yeah, we're not so clear on how that all works, but we know that this compiles.
Right, and this is the way we saw it in the examples. But then this part, what does this mean exactly? Like underscore game.
So underscore is how Rust lets you name variables that you're not going to use. So if you name a variable without an underscore in the beginning, it will be a compile error if you don't use it.
Right.
But you can tell the compiler, look, I need this here, but I'm not going to use it. so I'm going to put an underscore in front of its name. So if we were to come up with some validation rules for game, we would remove that underscore and write those validation rules underneath using
I see.
using
Okay,
the
gotcha.
variable. Yep.
And then right now, basically, this is just returning a result that says okay.
Right.
But you could write something else in there that used these variables and matched something or had
And
a
we'll
conditional.
see that.
Something.
We'll see that in the branch.
Right. And then links is sort of like database relationships. Like if a game always sort of owned certain components, you could say that games owned components sort of here, but we haven't done that here.
Right. We could theoretically use links to, like, if entry types were or if component types were entries, we could use link to sort of dynamically after the fact change what the game what the required types were for the game. And you'll notice I don't use links at all in anything, and that's because we don't want to be able to dynamically change what they reference, because that would invalidate someone's investment in that element, or it would change like the reason somebody thought this was going to be good is because it only linked to these exact things, and then that changed. That would change the sort of assumption of people investing in a component or an element, rather.
Yeah. Okay. So so let's continue. There's probably going to be a few more things of this kind here. So here's another struct, which is a mode, which again it has a command again. So this would be something that's sort of like, whatever is going to make the mode happen, essentially, or something like that.
Yeah, and there's the same sort of thing like mode types. Like this is how to run the mode, and we would have like mode launchers.
Right.
Mode launcher types, and people could put in their mode that way.
Yeah, it's interesting that that's not just the same. Why do you have to launch two things? Can't you just launch them in the same thing? And I mean, that's an interesting discussion to have, but there may be some reasons not to do it.
It's to decouple them. It's to say you can write one of these without having to write the other.
Right. And it lets them do more flexible things and whatnot.
Yep.
Okay, cool. So then here we've got the entry function. Really just we're making the entry. We want to be able to make this entry, and we don't want to have to put this whole thing for all of them in the thing later. And this is the recommended way to do that, is to actually just make a function that creates this
returns the entry. So it really just cleans up the define zone macro.
Right. And this is the same as the previous one, so I don't think
exactly the same, 100% the same.
In
fact,
stuff.
I just changed, of course I changed the name of the description, but everything else is the same.
Right, and all this stuff says mode now, and that's different. But everything else looks basically the same. Then we've got components. This one has a name. Interesting that mode doesn't have any string in it. Is there a reason?
Mode. So mode should have a name, and I think I maybe add that. Game should also have a name, and I think I maybe add that.
Okay, cool. Then we won't worry about that for now. Right. So component has a name. It has a type, which has to be a valid component type. In other words, something that has been named as a component type, basically.
Right.
And then data of some kind.
And I will note there's a underscore at the end of the word type.
Yeah.
And that's because type is a reserved word in Rust. And so adding an underscore at the beginning, which I often do in other languages, has that other meaning of,
I see. Interesting.
We're not going to use this. So I put the underscore on the end.
Gotcha. Okay, cool. That's good to know. That's definitely a good subtlety to be aware of. And here's the entry for components, which again looks the same.
Exactly the same. Yep.
So next one is format. So this one's got a string, and then it's got a vector of addresses, which would be the components that are part of that format.
Right. And this is the one that does have some validation.
So this one has a big interesting thing in it. This
Yeah.
part, I imagine, is all the same, though. Sharing
Yes.
public,
Yes.
native
Yes.
format, the struct we just made, the same validation package for entries. But then the actual validation, this part is the same, except I see that we have not used the underscore here because we're actually
Right.
doing things with that, with this variable that we've named in the input. And let's see what we're doing. So this is a function to try to check that all the component addresses are actually components.
Yep.
So we're taking for address in this in the vector of component in the vector of addresses that's inside every format that's called components.
Yep.
And we're turning it into an iterator, which is just the way you have to do this stuff in Rust.
Yep.
And then over that iterator, we're getting the result, which using a Holochain function that tries to get whatever's at a given address.
Mm-hmm.
And we're borrowing the address, I guess is what this is called
Yes.
often in Rust.
Yes.
Which is not exactly the same as
we don't want to give get entry ownership of address.
Right.
Actually, get entry doesn't want to take ownership of address.
Yeah.
Because otherwise address would be the memory of address would be freed as soon as get entry finished.
Right.
And we don't want that. We want address here because we might use it again.
Yeah.
I don't think we do, but get entry does not request ownership of address.
Right. And so this is a way of grabbing the data without any ownership. And also, notably, this is not you could also do a mutable version of it. Like you could borrow it in a mutable way, and we also don't need to do that here. So
right, get entry does not want a mutable reference.
Yeah. So we've tried to grab whatever is at that address. I wonder if this is the kind of thing we might eventually need to have some error handling here in case there actually isn't anything at the address.
It does have error handling. So if you notice, we're matching on the get result.
Okay. Right. Gotcha.
And there's an okay case and an everything else case, which is an error.
Right. Right. So I guess this is a nice thing about Rust is that this line itself, I guess, will probably never actually, crash the program itself.
Nope.
At worst, it'll just return something that we'll then interpret as an error here.
Yep.
So with get result, we're then matching that, and this is returning a result, and results are always of the form either okay or something else. Not okay.
Yeah. So get entry returns a result, and so will validation. Right? Which is
yeah. Right. Which is what we're doing.
Yep.
Here. So
yeah. So this code really, I would like to refactor it some. It's like deep and nested, and it's hard to tell. Like that okay down at the bottom just kind of looks like it's dangling. It's like what?
Right.
When do we get there? It's kind of hard to see.
Right.
So I don't actually refactor it. But this is where someone who's more experienced with Rust can probably help us.
Probably, yeah. This is the kind of thing where there's a lot of different ways to do it, and there's probably some really nice, pretty ways of doing it.
I think it even gets worse when I change it. But basically, what this is doing, right?
Mm-hmm.
So get entry returns a
result
option entry.
Right.
So inside the result is an option. Like it may still be a valid. It's valid for there to be no entry at that address, right? Even without like.
Right.
It's not an error for there not to be an entry at that address.
In other words, so if there's nothing at the address, this will still return. If I'm understanding you correctly, will still return an okay result with nothing with an option inside it that has nothing instead of something.
Right. Right. It'll be the option form, or it'll be the nothing form of option, not the sum form of option.
Right. So I see what. So what you're doing here is you're matching for results with sum with a sum option inside it. And inside the sum option is something of the type entry in an app entry.
The app form of entry.
Right, which matches entry type and any entry type.
and something that we're not going to use. Yeah, the value of the entry we're not going to use. We just care what the type is.
Right.
We want to validate that it is a component type.
Right. And so that's, if it does have this, then we're going to check that the entry type is component, which is one of the types that we're defining.
Yeah, and I think this component.into is where we need the try from. I'm not totally sure about what this is going. And if you see my comment, it's like I'm not. Is this doing what I hope it is?
Yeah, is this doing what I hope it is?
But I'm not completely clear.
Yeah, so I'm gonna assume it is doing what you hope it is, and try to describe what I think is that you're trying to do.
Yeah.
The into here is so that these can be compared properly. Is that the idea?
Yes. So if the entry type is, I'm pretty sure component.into turns into the type.
Right.
That is called component. And if it matches the entry type, then
is the into trying to
have that address as a component, and we can continue checking the rest.
Yeah, is the into trying to convert component into the same type as entry type, or is it doing something else?
Yes, so it's trying to convert the string component into the type that's expected in that spot.
Right. Okay.
For the type that can be compared to entry type.
Right. Which should be component, hopefully.
Right. So it'll be an entry type. Right. It'll be a Holochain entry type.
I see. Okay, I see.
Like app entry type or something like that. We would have to look up what they call that.
Right. Interesting. Okay. Well. Yeah. Anyway. It's trying to.
Anyway, this all is going to change, and I think I have a much better solution for it in the other one. But
anyway, so if that's true, then it's going to continue, and that's what's going to end it up here.
Well, it's going to keep going through the loop, so it's going to check the next address.
Oh, right. Right. So it's just going to continue. If it's
onto
not
the next address, make sure that every single one of the address gets to this part and continues through the whole loop.
If it doesn't,
because otherwise we just break out and return.
Yeah, we return that we found something that wasn't a component. Either way, if we don't get this okay with an entry app or an entry type, then it's going to return that. If we get that, but the entry type isn't component, it's going to return that as well. But if it hits continue every time, then it will return okay. It will turn
if we get through the whole list without returning an error, then we return okay.
Right. Okay. So there we go. We're checking that all the addresses in this vector actually return components. That's the idea.
Right. Yep.
And then again, no links. This is the one where I would ask: is there why not? Yeah. Why not say?
Yeah. So why not links? Because we want every format to be immutable. We want all of our elements to be immutable because we want an immutable thing to have a DAO around, to have to have curve bonds associated with. Right. We don't want to offer somebody investment in a thing that anyone can change out from under them.
Right. We don't want it to be so a format will have a list of components, but we want that list of components.
It's an explicit list in the type.
Right. We don't want to make a simple public function to add more components to the format.
Right, and links offer that, right? So links is
that's what we.
Oh, we're going to add a new to-do to this list, a new item to this list. Great, anybody can add that item to that list.
Right, and that's we actually don't want to make it easy. We
do not want
to make it possible to change, but only under certain circumstances, and probably won't start with that.
I think we don't want it to be possible to change at all. I think we say you have to make a new one that's exactly the same, except with this one difference, with this one added, or with this one.
Way to do it. Yeah.
We just make another one, and then that one gets a DAO, and it gets and anybody can invest in it.
Right. Yeah. Okay. Cool. Right. So we want immutability. Okay. So there's all the entries. Now we've got these functions for handle, contribute, game. So this is the idea here is that the final, the actual Holochain app will have a function called contribute game probably,
Yep. Yep.
which would be someone trying to add a new game to
Yep.
the system.
Yep.
And this function is what, like when that function gets called, it's going to sort of call this function essentially, right?
Yes. Yes.
So it's called handle contribute
And
game.
we're going to map those in the. We're going to map the contribute game function name to this explicit function in the define zone.
In the define zone, right?
Yep.
And so this function takes a game. It's going to return a Zome API results address. So a special type of address.
Yep.
And let's see what it's doing. So HTTP debug format exclamation point contributing game. Yeah, this line I don't have a very good understanding. I could guess.
Yeah,
but,
I don't totally either. I saw it. I'm copying it from another repo.
Mm-hmm.
My guess is that this is so the format macro. I kind of recognize the syntax from other languages. So that colon question mark probably means whatever the default string representation of the next of whatever's in that spot, right? Like so the curly braces represent like holes in the string that are going to get filled in by the next series of arguments.
Yeah.
And so that'll just say contributing game, and then it'll take whatever's in the first spot there and just use its default string representation.
Right. That's what this colon question mark means.
Yep. Gotcha. We can probably specify like colon S is my guess for string, and it'll be an error if game isn't a string. But we can do colon question mark to say we'll take anything and we'll just try to make it a string.
Gotcha.
Use its default representation.
Yep. Okay, that makes sense.
And then there's probably some Holochain debug piping that we can get access to and like see it. I haven't looked into that yet, and I'm not sort of aware of how to use it. But I think it's worth doing this so that when we need it and find it, we'll have it.
Right, and then this entire function call is also getting this Rust question mark thing.
Yep. So if that's an error, we're in a panic.
Right.
We're just going to return that error. Yeah.
Right. Okay. So then next line, let game entry be an app entry with the type with the entry type game and the game.
And the value game that
right.
yeah.
And the game that you're trying.
Yeah.
To
I've got some learning of Rust to do here, and hopefully when we get people on the stream, they can help us understand why the into is required there and so on. My guess is that entry is pretty entry app is a pretty generic data type, and those derive methods are giving traits that sort of are figured out here, but I'm not totally sure.
Right. But in theory, this makes sense to me. It may not be the very best way to do it or whatever. But we're making a new entry of type game that we wanna enter into that we want to commit somehow, and then here we're trying to commit that entry. We're actually borrowing the data from the entry, and then trying to commit, basically put it onto our local chain and then get the address that we put it to.
Yep.
And then we're returning a result with the address inside it.
Yep.
So this takes in the game that we want to contribute, and it
if we can't commit it, it'll return the error form of Zome API result.
Yeah, and so generally describing this function, what it's trying to do is you're putting in the game you're trying to contribute, and it's giving you back the address that it put it into, put it at, and then I imagine these are all doing the same thing.
Yes, those are just they're all repeated functions.
Right, so that makes sense. And we've got that for our four elements here: games, modes, components, and formats. And now here we've got our define zone macro. So you can see our entries. These are the types of data we want to put into the chain. And these are the functions that we define to create those to call the entry macro that we need as an input for this part of the,
so this is
zone.
much cleaner. We can look at define zone and just scan through and see all the entry types.
Right. So this is very nice
without it being that big.
Yeah. As opposed to if we had to put this type of thing 4 times. And
yes.
So this is much nicer looking. Then this Genesis thing, which this is just what we've seen other people doing, and it just sort of helps the local chain get started. I think.
And we have no sort of initialization requirements yet. Right. We may. I don't know.
Right. Yeah. We're not sure what they would be yet. We can think of some things that we might want to use.
I mean, if we want to charge people to join the network, we could put something like prove that your Bitcoin address has paid us this much or whatever. But,
or something like that.
I doubt that'll.
Yeah, so
that's where we're gonna go. I doubt that.
We probably won't start with anything like that for a while, I would assume. And then these are all the functions that we want this Zome, to kind of expose to the rest of the app.
Yep.
And their contribute game and contribute mode for each of the elements. And so when you're defining these functions, you have to define the inputs and outputs that you're looking for, so that that you can communicate what those what you're looking for to other zones, and then the name of the function that is get called inside of the zone, which is all these functions. Right. And so we've got that for the four functions we discussed.
Yep.
And those are all the same. And then we've got traits. And so maybe talk about this a little.
Sure. Yeah, my understanding with traits right now is that HC public is the only trait that's implemented, and it's just required. And that's just that's sort of an artifact of the how early we are in this, and it's a preview developer preview release, and this is just one of those quirks that you just do it this way.
Right. And so what this is saying is basically that all 4 of the functions that we've named are going to have this trait
are public.
HC public.
It means anybody can call them.
Yeah.
Yep.
Yeah, which is a thing you see in lots of apps, right? Naming functions public or private or other variations like that. Okay, so that makes some sense to me. So basically we've got hopefully a Zome here that can help people add these various types of elements to a local chain.
Yes, and what it does is it helps validate. It gives you trust that what other people have added is valid.
Right. Right.
And then Holochain gets you all of those, gets you all of the contributions from everybody.
Right. 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 Yeah. I feel like very bad understanding of how different agents actually communicate to each other.
Yeah. I think there's and I'll try to find this, but there's just understanding a distributed hash table, I think will help.
Right. But even like on a basic level,
the architecture of a distributed hash table.
If I made a front end for this app, that had a bunch of little icons and you could submit these different things, and then we both ran that. Are they they're not talking to each other yet, right?
I think they would be, yeah.
Right, so I guess I'm just wondering
how.
What's going on there?
Yeah.
Just not
how.
I kind of feel like I have some understanding of once they have a connection to each other, what they might be doing. But I'm not sure how that connection's being made.
So each needs to join the network by knowing at least one member of the network and knowing their IP address, right? Mm-hmm. And then Holochain, I think, handles some of that. And the conductor, not the conductor. They've named it. Right. The conductor kind of handles that part.
Gotcha.
And you also have to have the same sort of Genesis output,
Right.
and the same DNA and all of that. So yeah, it's a little hand wavy for me right now too, but
Okay, I see. But so basically, the stuff that we're not, all the Holochain stuff is claiming to just magically do that entire part of
handle that.
it.
Yes.
Cool. Great.
Yes. Yep.
Um,
Yep.
okay, cool. So yeah, this code makes sense to me then.
Cool. So let's look at so actually let's stay here for just a second. So what I noticed here is that we've got these 4 types, right?
Yeah.
And I wanted to be able to well, yeah, let's scroll down actually to the contribute functions, the handlers. And sort of notice how similar they all are, right? They're all doing the same thing, right? I was just like,
Yep.
I might as well have copied and pasted those and then just like find, replace game for mode and game
Right.
for component and so on, right?
Right.
So this is sort of, it's called a code smell, where you can kind of like, you'll get into situations where you'll feel like you're doing this, right? And it'll smell a certain way.
Okay.
Right. It's like I'm just repeating myself over and over and over again here.
Yeah. I guess that's the thing.
There must be something I can do.
Right.
And so I wanted to have a general,
smells, right? Whenever you're typing the same thing twice, you're like, I must be doing something wrong.
Yeah. And there are plenty of reasons to write the same thing twice, and I think clarity is often the biggest reason, because you can generalize way too far. Like the data model thing with a self join can implement every single data model, right? Like that's just something that you have to trust, and like the data architects tell me that it's so, and I trust them. But that's not helpful, right? Like I want a little bit more structure than that, just to be able to understand what's going on. But this is obviously a little bit more, and we rather than working at the level of game and mode and component and format, we can work at the level of element and make element generic and make element capable of representing games and modes and components and formats. And Rust gives us a really nice way to do that, which is the enum. So I made an element type, which is an enum of game format. So we can take a look at that.
Okay. So that's what this other branch is about.
Yeah. Yep.
Okay, cool. So let's check that out. I assume we can stay with this same file.
Yep. This is where all the code is, and then this file does actually have tests. So this branch does have tests, so we can go look at that later.
Cool. Cool. So shall I go through this now and do the
sure.
same thing?
Yep. I will note that I added this standard convert try into. I'm using this try into thing, which is sort of part of that type inference system that I'm not totally clear on how it works. I kind of just banged at it until it compiled.
Right. Okay, cool.
Well, but yeah, we can go through it.
Let's check it out. Cool. All right. So this, other than that, this beginning stuff is the same, and probably
pretty much the same. Yeah.
To go through anyway. This struct is the same, and then this is new. So it's got this derived thing that everything needs to have, and then we're creating an enum called SMG element.
Yep.
And that has, so actually, do you want to talk about enums for a second? Because I feel like I don't have a great understanding of what's
Yeah. So enums are like
to a struct or other things like that.
Yeah. So they're a type, and they basically represent a set number of options, a set number of sort of data structures that should be treated as the same type, right? So there are some things that we just do with SMG element, and we don't care whether or not they're games or modes or components or formats. So the result type is an enum, and the result type has exactly 2 forms: the OK form and the error form. And so basically we want to be able to match like pass SMG elements around and sort of state that a certain thing and a certain function has to be an SMG element, but then also match on which type it is sometimes.
Right. Okay, that
Um,
makes sense.
yeah.
So inside of this particular one, we've got the things we were previously just defining as individual
Yes. Structs. Yep.
structs, game mode, component, and format, and this
Yeah.
ice. Oh, these are slightly changed. So game has a name.
Yeah. I added name to
Um,
everything.
So this still has this command. The rest of the stuff is mostly the same. Everything has a name, but they aren't all exactly the same too, which is you know, I guess
Right.
important. Although they weren't the same before either. But that all makes sense. And then this is a new function, check string.
Yeah. Yeah, this is just a little tiny helper function. I wanted to like just check that the string wasn't an empty string. In a lot of my validation, so like you can't give us a name with that's just empty string. You have to give us an actual name, for example.
Okay, interesting. There's some stuff that's confusing to me, but
So yeah, this is going to check string is either okay or error,
right.
and we're going to match on it. And if it's an error, we want to sort of be able to accept a message for what we want the error message to be. And then we're checking the checking the string for length.
Yeah, what is this result type?
So a result takes a type and an error type. So like
okay.
so this okay open close close.
Right.
That actually means okay unit. This like open close is the unit type. It's just like the simplest most basic
Right.
like no type, just like it's there so that we can put it in an okay, and that's like okay is the only like signal that we're trying to send.
Yeah, I just hadn't seen this thing where result had
Sure.
sort of like two elements inside of it.
Right. So there's two types.
Yeah.
Result takes two types. It
Right.
takes a type for its okay.
And a type
its
for
okays need to be of that type, and then its errors need to be of that other type.
Right. Okay, cool. Okay, makes sense.
Yeah.
All right. Okay, and then we've got a single function here for just entering any element.
Yes.
Any SMG
Yes.
element. So that sounds
Right.
cool. So let's check this out.
Right.
So again, it's gonna output a validating entry type. Again, it's got an entry macro inside of it. But this time the macro is for SMG elements. So it's generalized for all elements. Its native type is this. Still got the same validation package, but then the validation is going to be something.
But that whole section of code from name to like validation package was repeated 4 times.
Right. Yeah.
Now there's only one copy of it.
Yeah. And so in here we've got basically something that. Well, actually, let's just go through it. Okay, so the validation, it's got this standard thing that we don't totally understand, and then it's taking an element of the type SMG element, and we're matching that to if it's an SMG element game, which has these fields.
Right.
Then
so there's some syntax here that I should cover, I think. So notice that name and CMD don't have colons after them.
Yeah.
So that's a shorthand for name : name, command : command.
I see.
And that means that we're going to be using those. That's being destructured. Can we go? Yeah. So that's being destructured. The element that was passed into this validation is it's a game. Its name has been bound to name. Its command has been bound to command, and we're not binding required component types or optional component types because that's got the underscores there. So : underscore just means don't bind this. We're not going to use it, or bind it to underscore. We're not going to use it.
Right. Okay. Right. So we're checking these two, and we're checking that they're not empty, basically, right?
We're just checking, right. So in order to be a valid game, you have to have a non-empty name and a non-empty command.
Right. Okay, cool. That makes sense. And looks like we're going to do similar thing for mode. It doesn't have these two, so we don't have to do this part of it, but we're going to check the same. We're going to check name and commands.
Yep. And there is a, notice that there's a question mark after the first time.
Just for name. Yeah.
But not after the second time, and that's the same. Yeah. So if the name is empty, we don't have anything else to do. Or like if the name is empty, we don't have anything else to do. We'll just return that error.
Right.
But if it's not empty, we have another check to make, and then we're just going to return the result of check string there because it's either okay or error, which is exactly what we want.
Right. So you could put a question mark after the second one too, but it would be redundant basically.
It would be redundant, right? Because we would have to say like okay equals check string question mark return okay.
Right.
And so this is just a simpler shorthand.
Yeah. Okay. Cool. Yeah, that makes sense. Okay. Then we've got component, which takes name and type and data, but we're not gonna be dealing with these.
We are going to be dealing with type underscore, right?
Oh,
so that's
okay,
not
right.
type colon underscore.
Right. So
Right.
this is what it's actually called in
Yes.
the component
Right.
definition. Right.
Right.
Okay. Right. Okay, so we're not checking data because presumably that could sort of be anything, and we're
Right.
not telling you.
And that could be anything, and we don't know what its format should be because we don't know what games in the future are going to need.
Yeah. And you could conceivably, like with these other things, you could conceivably have a component that, had a name and a type, but actually didn't need any data. Maybe there's
Sure.
a game
Yeah.
that the only components just need names. Basically.
Yep. Yep. Theoretically.
It's possible.
Yep.
Right. So we're checking the string for name, and we've got the question mark.
Actually, Scrabble's a very good
right
example of a game that would not need a data type, that would just completely be dependent on the name.
Right.
Yep.
Then the name is the rules, basically.
Yep. And the format is the sort of legal Scrabble dictionary.
Right. Yeah. And each entry in the only meaningfulness in the dictionary is that the word is in there, and it.
Yep.
And it
right.
It has a name. The word has a name.
Yep.
Cool. Right, that makes sense. Okay, SMG element component, checking the name, got the question mark, because this is not the last step, we need to keep going.
Right.
Or we can stop early if it messes up. Then...
Now we need to destructure type,
right.
get the string out of that component type.
The component type. So what is going on here? Is component type something?
This is further destructuring. So remember, the type of component type is component type of string.
Oh. Right. Where?
And so
we defined that somewhere, right? Oh yeah, here, component type.
Yep. So type is a component type. It's not a string. It's a component type.
Right. Okay.
So we need to pull the string out of that component type by destructuring it, setting the variable type name to equal to the type, right? And it this destructuring statement pulls the component type wrapper off, matches on the component type wrapper, and then sets whatever's inside it to type name in the same way that the match statement does. And then we're going to check the string on the type name.
Okay, I see.
And make sure that it's not empty.
Cool. Okay. Makes sense. And then the last one here, format. We're going to check name and component, so we're checking the name for empty, and then we're doing this more intense check for the components, similar to what we were doing before. It looks like it's a little bit changed because of the other changes that we've made here. Here's the try into. Right.
So notice here I do have the question mark on match HDK get entry address question mark.
Yeah.
So basically, if there's an error in getting the entry for that address, like, we're done. if any of the addresses have an error in get entry, we're done. And so I don't have to match on the OK here. I can just match some entry app. And then we're actually going to match on the result because we need to make sure that it matches SMG element component. And if the result matches SMG element component, we don't care what the name, type, and data are. As long as it matches that data type, we're good, and we can continue. Otherwise, it's a non-component component address.
Right.
And I still am not totally 100% sure that the try into there will correct. Oh, I guess maybe I am because I'm testing it, but the try into there will match components. I'm just not totally sure why. I couldn't like run through what the compiler is doing there, and I would like to learn that.
Right. And like a regular into doesn't work here.
Yeah. So try into returns is a result type. So
right.
We either are or are not able to treat this as the type that needs to be here, and so there's a question mark after that as well. And so if we get an error there, if we can't convert whatever we get in API result into what we need here, then we're done. It's an error. This is not a component address.
Right, and it will not try to do the match if that happens, right?
It won't. Nope.
Yeah.
Okay. No, when it tries to evaluate the statement API or the expression, when it tries to evaluate the expression API result.try into, it will either just like quit and return the error if that's what it resolves into, or it'll then put the result or the OK, it'll like strip off the OK and then throw that into the match.
Oh, does it strip off
That's
the OK? Yeah, why is it stripping off the OK?
Because it handles it sort of handles the result stuff. So it either returns the error or it like jumps you into the OK part.
I see. Okay. So then we're just matching what's inside of the OK, if there's an OK.
Yep.
And we're matching it to say, is it a component with, and then should I be confused as why these are curly brackets? For some reason, that looks a little unfamiliar to me.
Yeah. So the component, I guess I'm not totally sure there. Oh, because it's a struct type.
Okay.
So that's just the syntax for a struct type.
Gotcha. Right. So we're matching it with SMG element component, which is supposed to have these things in it, but we don't need it. We just want to make sure that it has something for each of these. We don't care.
Right. We just want to make sure it matches this type. We don't care at all about the data inside.
But you have to include this, right? You couldn't have just said SMG element component. You have to.
I'm pretty sure.
This. Okay.
Yeah, I don't remember if I tried it without it. I probably did. But that would be something to try if we wanted to.
Right. Interesting. Okay. Cool.
Yeah. So in order, if you go look, sometimes it's a curly and sometimes it's just a parentheses, and it'll match whatever the sort of syntax of creating the type is, or like not creating the type, but stating the type.
Yeah.
So if we can't match, if it's not some entry app like that, then we return error. The component does not match.
Right, and it's a non-component, and then this one will happen if this returns an OK, but that OK does not have inside it an option that is some app entry.
Right.
If it's something else,
we gave it an
It's
address
gonna
for
say
some other
it's something
thing in the
else.
system, right?
Right, it's something
Like
else.
maybe we gave it a node address or something.
Right, whatever other kinds of addresses there are.
Yep.
Okay, that makes sense. Right, so that's that validation thing.
Yep. And if we get through all of them, then it's okay. That is a valid format.
And then this doesn't
Again,
link to anything
no link.
for the same reason as before. And now we have much less to do in the rest of this code. So we've just got one function we need to design here, which is handle contribute element, which I imagine is very similar to what we had before.
Yeah, exactly the same, but it's a SMG element rather than each element type.
Right, some relatively minor to-dos.
relatively minor points. Yeah, that this is where we create a curve bond. This is where we create
other program here.
Yeah.
Right. Okay. So that's another conversation. But
that's
that makes
100 other conversations.
It does make sense that so this is the point where we want these things to happen, right? You're contributing a new element, and so the setup,
every single one gets
setup of that element needs to be triggered here. And we really don't have a clear idea of exactly how we're going to implement these things, but this is certainly about the right timing for it. Okay, and then this function handle get element. We didn't have any get functions in the last version, right?
Nope. But when I was writing tests, I realized I wanted to check that I could create something and then get it back out. So I made a get element.
Yeah, that makes sense. And so let's check out what this does. It takes an address of type address, which I guess is probably something here it is.
That's from the
HDK.
The HDK.
Yeah. It's just funny that you can reference that just by doing capital A address. You don't need to. I wouldn't think that just from looking at this import, but but whatever. Where are we? Okay, here we are again. Right, so it takes an address. It's going to return an API result of this type that we've defined.
Yes.
And it's doing a match for get entry at a copy of that address. And if it's okay, and inside the okay is an option of some entry app that is of API results, or where we want to look at the API results. Then we're going to return a result that is the API results tried to turn into what?
Whatever's supposed to be there. So it can figure out whatever's supposed to be there by looking at the function signature. Our return type is supposed to be Zome API result of SMG element. So OK is a Zome API result.
I see.
Inside of that, it should be an SMG element.
Right. So it's trying to.
Yep.
Trying to do this stuff.
And if it can't turn it into an SMG element with that question mark, it'll just return that error.
Right. Then it'll stop and return
straight from there. Yep.
And then if it doesn't match that whole thing, if it's anything else, then we're saying we didn't find an element. An element here refers to like our element, not
SMG element.
Kind of generic element. Because it could have found something. It just means it didn't find an SMG element.
Correct.
Okay, and then our defined zone is going to be way shorter here since we've got only one entry type, and we've got just the two functions, contribute element and now get element, and then we've got the trait is the same.
Yep.
So yeah, in general, that smells a lot better.
Yeah, it does. It does.
Cool.
Yeah, and man, the enum type and the matching stuff from Rust made this really clean and nice. It's feeling very powerful. I'm liking Rust a lot.
Yeah, it seems really cool. There's some stuff in it that, as someone who's never worked with anything resembling, like a systems language, is weird for me, right? Like some of the question mark stuff, some of the ampersand referencing that have to do that stuff's in there because of the way Rust deals with memory, and it tries to deal with it in an efficient way, and that's just not something I'm used to dealing with these high level languages that just sort of
Right.
say we're going to do it the way
JavaScript is
we
like,
do
we're
it.
going to do memory stuff and you don't
Right.
have to think about it.
Exactly. Yeah. But it's really not too crazy.
No.
Just a few things that are like, oh wow, that's pretty alien to me.
Very cool.
But yeah, so that seems really cool. So should we check out the test?
Yeah, let's look at the test.
Info? So that's going to be, where is that? All the way up. Oh, all the way up. All the way up the tree. Okay, so so the testing is done in JavaScript.
Yes.
All right,
And
so
a lot of this I kind of copied from other things. A lot of it was kind of already in here from the sort of HC command that created it. But
right. Cool. Okay, so we're importing some stuff from Holochain.
Yep.
Here. Then I don't know what this is.
I don't either. I mean, it's some way that Holochain is it's running tests. Like, it's not testing our Rust project Zome. It's testing the result of building that Zome.
Right. So it's testing the compiled Holochain app.
So it's setting up like a test conductor and maybe more than one, and running the compiled Holochain app.
Right. Okay, so this is some setup thing that it needs to
will likely be for multiple zones, yeah.
DNA path, this is just where our this bundle.json is what
HC what is
HC
it called? Build HC
DNA into, is that right?
Yeah, whatever the HC like build command does.
This is creating some kind of test agent.
Yep.
This is, I guess, turning using this DNA path to create a sort of a version of the DNA we can use to test, I assume.
Yeah, config. So that's config.
Yeah.
The config DNA is at this DNA path, and so now we've got some DNA that we can.
Right. So this gives us
that we can throw into the
test
instance, which is config.instance. Right. That's only there to be able to put into config.instance, which needs that DNA object.
Right. So I assume this is now somehow simulating the idea of an agent named Alice who has kind of like logged in, so to speak,
and is running Holochain.
Right.
Yeah.
Yeah. So she's now running a Holochain app with this DNA. That
kind of thing. Yes.
New scenario. I wonder if this is some kind of like recording type thing, and maybe that's why it's called tape.
Yeah, so it's part of I'm not really deep into it, but it's part of the test scenarios, or like in this scenario we want to make sure that all of these things are true. So a scenario is this scenario.run tape. Alice can contribute to valid elements is like the name of the scenario, and then function gets called.
I mean, Holochain's naming conventions are like kind of fun.
So tape is a third party, not associated with Holochain. It's it's the test framework that they've decided to use.
Gotcha. Okay.
Yep. It's nice. Nice, simple.
Yeah. So here we go. So we're creating a scenario with this instance.
Yep.
And here now we're writing some tests for it. So here we go.
Yep. So I have there's maybe some description to some context to give to the way I wrote these tests.
Okay.
First of all, this destructuring up top here, we get T in the first place.
Yeah.
Right. So this is a function that takes a T and an Alice, but Alice is inside some object, and so we're just ignoring the outside object and just taking the Alice property and naming it Alice.
Interesting.
Yeah. So that's JavaScript destructuring, which is pretty cool and pretty powerful. But that's what it is. So now we have Alice here and T, which is the test or tape thing. Right. So I'm going to be collecting the component addresses and the component mode addresses. I don't know why I say component mode addresses there. Maybe we'll see. But I'm going to be collecting those because I'll be using them in later tests.
see.
and then I make this list of test cases. And these are just sort of metadata describing a test case. So
Right. So here's
when
a game element.
basically when an element is this, the valid should be true. When an element is this, the valid should be true. When an element is this, the valid should be false, and the error should be this.
Right. So
empty game command, right? So command is the empty string, so we want to make sure that that does not validate, and its error is empty game command. So this is a list of like elements and whether or not they should be valid and what the error should be if they're not valid.
Oh, right.
And we'll use these down below.
Right. So this is still setup stuff, right? This is
all set up, right? This is just each one of these objects is metadata for a test case.
Right. Okay. Yeah, this all makes sense. We've got examples of all the different elements.
Yep.
And you're trying to think of as many errors as you can, sort of.
Right. Yep. So that's why I'm collecting addresses. So I want to collect some addresses that are component addresses and some addresses that are not component addresses. And I should probably, I don't know why I call that component mode address. It should just be mode address, but
yeah, who knows?
That must have been late at night or something.
Yeah, maybe. Okay, so we set all that up.
Right. So for each test case, we're going to run this function that takes the test case and does this stuff.
So for each of those cases, we're going to take this instance, Alice.
Alice is going to try to contribute the element.
And I assume this Alice is going to be
the
scenario?
Yeah. So it's the Alice. So it's the Alice that we were given, right? So, the instance, it's the agent that has the instance. I'm pretty sure they have that all figured out on their end.
Right.
This is Holochain's setup that they're giving us the agent that matters. That's running the instance.
Right. So this is the agent running the instance, and they're going to try to call from the Zome elements the contribute element function, and they're going to try to input as
it.
Yeah, they're going to
parameter element.
The parameter element, which is the test case element thing. So, for example,
the cases element. Yep.
That. For this one. Then, if
the case claims that it should be valid.
Right. Okay. Right. So if the case claims it should be valid, then T, which I already forget what that is.
So T is the tape, is like the assertion library. So basically, we're telling the testing framework that these two things should be equal.
Yeah. So
and if they're not, give us some output that lets us know that failed.
Right. So we're testing is contribute result dot error undefined.
Right. So contribute result should not have an error.
Right. And if they are
property.
Equal, then it'll continue, and if they're not, then this test will fail. Right?
Yeah, it keeps continuing. It just so the testing framework just gathers up all of the results and prints them out at the end.
Right, but this particular one will fail when it tells you.
Yes.
Right. Okay. And then get result. Wait, what's this? Contribute result. Get result. Alice call elements. Get elements. Okay. So now we're trying to get.
So the test here is to
get that same element.
Contribute an element, and then if it's supposed to have contributed, try to get it back. If it's supposed to have errored out, we're not going to try to get it back because we know we're not supposed to be able to.
Address contribute results. Okay. What is that?
So so the way these are translated into and out of this is a little bit of like Rust syntax making its way here, and that's part of the like automatic default JSON stuff. So contribute result is a JavaScript object with either the key OK or the key error, depending on which result was there. And then the value at that key is whatever was inside the result, right? So error would be the error message. OK would be the object that it created.
Right. So okay, I see.
Or the address. I'm sorry, the address. So
Right.
right, because we're returning the address. So this is going to be if we contribute an element successfully, we get an OK, the address.
Right. The get element function is supposed to return a result that has an address.
Get element takes an address.
Oh, right, and right. So it's supposed to return. Right. So this is the input that we're trying to do there.
Yes, and what we want the result of what we contributed to be gotten back out.
Right. So this is what we've tried to grab.
Yep.
Deep equal.
Yes. We want to make sure that we want to traverse the whole object and check all of the elements in any, whatever the structure of this thing, we want to check every single piece of it.
Wow.
So that's what deep equal is.
That's pretty cool. Okay, so whatever was inside the result that we got from this.
Yes. We want that to match the element we put in originally.
Right.
Yep.
Right. Okay, that makes sense. Then if get result.
This is just where I'm collecting the addresses for later use. So we're pushing on to the sort of mode, if it's a mode.
Right.
If what was at the OK, what was inside that OK has a mode, has a property mode, and if it's the mode type, it will, and only if it's the mode type will it. Otherwise, that'll be undefined because of the way JavaScript doesn't care whether you're accessing something that exists. So if it's a mode, if what we just made was a mode, then we're gonna push its address onto the mode addresses. And the reason I want to do that is I later want to. I'm gonna be trying to create an element that is a. Just. This part is we're collecting mode addresses and component addresses into that array.
Right.
And we'll get there. We'll get to why we're using that.
Push contribute result. Okay.
So component mode address and component address are all those are defined in outside of this function, so it's referencing that of more general.
Yeah, that's this stuff.
Yeah,
but
yeah,
I guess what I'm confused about is
I have some test cases.
Right, but I thought that
if it's a component, if get result, okay.
Yeah, I get the idea. I thought that mode, why is this a thing inside of OK? Because I thought this was just a type. Oh, I guess it's, never mind. I guess it's just that way here. Interesting.
Yeah, so it has to do with the way that Holochain's default JSON, the sort of all of that stuff that was derived about stuff, about our entries, the way it translates that into JSON is that it will use the name of the enum as a key in an object.
I see. Okay. So this is the way you would really submit a mode when doing contribution.
Yes. And that's the way it would come back. Right. So it would either look like that or it would look like component.
Right.
Element component.
Okay, cool. Okay, so that makes sense then. So if it's a mode, we're going to add it.
And the way JavaScript does that, if mode isn't even there, that's just undefined, and undefined is falsy, so it won't go into that.
Right. Yeah. It just won't do anything.
Yep.
Right. So if it's a mode, we add it to mode addresses. If it's a component, then we're going to add it to component addresses and component.
Oh, I see. That's why I call it component mode addresses. I wanted a mix of component and mode addresses.
Right. I see. Okay. Yeah. where were we here? So this if is this one.
Yep.
So if the original component, case that we're trying is not supposed to be valid,
Right.
then we're gonna assert that the contribute result, which we made here,
Yep.
is undefined, and that
Yep.
there's an error. Wait, no. There's three things here, which is how does that?
So I think the last thing is like a message that, so when the test framework like compiles all of the results together, if there's a failure, it'll like print out next to it whatever's in the third spot. You don't have to put anything in the third spot, but if you put something there, it'll print it out next to it.
Mhm.
And I just wanted to know which one was failing, so I
I
put its error message, which is kind
I
of
see.
unique in that spot. Like it was supposed to be this error message, but it wasn't.
Right.
Is kind of what I'm saying there. So the one with the error that we wanted this error message didn't have that error message.
Right. So we want. Yeah. Okay. Got it.
We want okay to be undefined because we don't want it to be okay.
Right. This is testing that it's the ones that were supposed to fail failed.
Yep.
Which would, if they failed, then okay is undefined.
Yep.
Okay. And then this one is contribute result error internal.
So this has to do with the way that Holochain is formatting the like failed validation error message. So it's a contribute result. There's an error. It's an internal error, and that's all sort of. We want to parse that JSON, and then when we parse that JSON, the resulting object has a kind, and that kind is validation failed.
This is just where. This is where Holochain was storing this, basically. Right?
Yes. Right.
Yeah.
Right. Exactly.
So you just like looked at the object and figured out where it was.
Right. Parsed the part of it was JSON, and then looked in the part of the result, the parsed result that is a validation failed.
Right. Okay.
And if it's not that, like if that's not what we got,
then this
that should be what the error was supposed to be. Yep.
Right. Yeah. Okay. Cool. So we're doing that whole process on all these cases.
Exactly. Yes.
Seems good. And
yes.
It worked.
It did. It did.
That's cool.
Yeah. So I think this shows that we catch that my like question like try into statements are doing what I thought, because we've got this component mode addresses, we've got that mix, and it's erroring with the correct message.
Right. Cool. Well, that seems awesome. Yeah, I mean, one question I still have is like, so where is Holochain actually storing that data? Like, is it just like somewhere on your computer?
Yeah. So actually, maybe what you should do. Do you have this downloaded on your machine?
I can grab it.
Okay.
All right. I still have the to-do app running.
So yeah, what we'll do is we'll go through and we'll run the tests, and maybe we can talk about like what's happening there.
Yeah, that sounds great. Cool. Yeah. Let me see if this is on this. I probably haven't added this to the stream.
Oh, I see. You haven't installed Holochain on your laptop?
No, I have. I just haven't set up window capture for terminal.
Oh, gotcha.
Yeah, no, I did Holochain already.
Nice.
Oh man, that would have sucked. No, I was not that irresponsible. It was of course much easier to install on this machine than it was on the Windows Ubuntu.
Hey, looks like we got a new follower. So, Cithalis, thanks for following. I don't know how long ago you did that, but I just saw in my in my email. I don't have the right notification set up here, but I did see it. So thanks for the follow.
Yeah,
Glad
no,
you're
that's the
glad you're
professional
enjoying
way
the stream.
All right.
Sorry,
So
we're in a little
we've got that on
lull here, but
it should go down here somewhere.
just want to get this set up so we can
All right.
see these tests run.
Right. So yeah, I've got it here. What do I need to do? I just
So I'm still seeing. Can you share that window in
yeah. Let me
the
change
Hangout?
let me change the present to just present my whole everything.
Okay.
Present all I am. Present my darkest secrets, please, Google. Are you sure you want to share your darkest secrets with us? We might sell them.
We might sell them.
We might sell them to people. Okay, so so here we are.
Okay, yeah, I see that now. Okay, good. Yeah, you're on version 004 alpha.
Yep.
I think you just type HC test.
Right, that's what I was gonna say. I think it's probably just a command away here. I mean, it'll need to do some stuff, but
yeah. So let's see. It is right. It's building everything first, right? So
I haven't
dependencies.
I haven't compiled anything in this repo. I just downloaded it, so it's got to do everything.
Yeah. It's packaging. Packaging is the term that they use to create the bundle.json. And actually, that I have found that to be a little bit confusing because the flag is dash, like if you just want to say, if you want the long name for the flag, you can say HC dash dash package, but the short name for the flag is HC dash B, which stands for bundle.
Oh.
But I would expect
that sounds like
to sort of.
That sounds like one person named it after what Holochain does, and another person named it after what Rust does. Like one of
something like that. But yeah, if that could be uniform, that would be great. Like HC dash dash, and maybe even name it package.json. Although I see why they don't name it package.json because that's the
JavaScript thing already.
That's right. That's the node.
Yeah.
That's what the node file is called. So I mean, maybe it's HC dash dash bundle.
Yeah.
I don't know. Or call it HC package.json.
Yeah, you can make a comment on the HDK.
Yeah.
About that.
Yeah. I think that would be worth noting. I mean, it's not the end of the world. I can remember that. I mean, I learned how to use Git, which is leagues worse.
Uh-oh, this is a little bit stalled, and I don't know why. What are you doing?
Okay.
What is it trying to do? Oh, that's going again. It's just going really slowly.
Cool.
Updating Git repository. Now, why is it updating that? Interesting. Okay, well.
Yeah, so cargo build does, like, it's got, what's happening is it's installing from a Git repository.
Right, but
so
I have this on my computer already, but maybe it.
But not in this. Right? Like it's. Yeah.
Fair enough. All right. Well, in the meantime, another thing that I wanted to do, on this for Squad, would be just to update the README a little bit with a little bit more info about what
that'd be great.
What you were imagining is the scope of the project.
Yeah.
So yeah, I wanted to do that here. So
yeah, so I imagine the scope of this to be like if Set Match Games is to Valve Set match games is to Valve what Squad is to Steam.
Right. Something like that. Is that even how you write analogies? I don't remember.
Yeah, there's like a 3 dot. There's like set match games : Valve, but it's like it's vertical. There's like it says colon with a period next to it. I think.
Colon with a period next to it?
Yeah, that's like 3 dots. 3 dots in a triangle.
Here or I don't remember that at all. They took away analogies off the SAT before.
I think that's fine. We don't need academic rigor here.
Yeah, I just curious.
Yeah. So this is where game makers and game balancers and component creators and everyone else and game players all come to submit their contributions and also browse the contributions that have been submitted. And then also we're exposing to the public all of the sort of internal things that Valve is doing for Steam, we're letting the community do for Set Match Game.
Right.
So all of the like deciding, accepting it first of all, and this is going to be a big question, right? Like, and this is why we need a sort of overseer DAO that can like remove hate speech and things like that.
Right.
But the sort of accepting games into the system and organizing them and sorting them. But yeah, game vetting is done by the community of investors in the curved bonds. Yep. And right, so we're setting up a market that ideally, if we do it correctly, this market will fulfill that role. I think it's really actually important from this early to start stating and thinking about how to remove inappropriate content.
Right. Yeah. Or how to treat it.
And how to determine what is inappropriate.
Right. Because different things need to be dealt with in different ways, probably, right?
Yep. Yep.
Yeah, I don't know.
But
that's a good question.
at the baseline, right, we need to be able to remove hate speech.
Right. I think that, like, for you and I, the way to think about this is probably what should people be able to decide to do, right? Like, we don't want to be setting up like a definition of hate speech right now by ourselves.
No, but we need to think about where in the system that lives.
Right, and I think we need to think about where in the system people might decide what to do about a piece of content they wanted to remove, like and what powers they would want to exercise on it.
Yep.
So we want to make sure that appropriate responses are possible and good decisions are possible.
Yes. And we believe now that DAOs are capable of that.
Right.
If we come to discover that that's not true, we may scrap the project.
Right. Yeah.
Or install ourselves as dictators over that.
Right. Or maybe like, because I do think it can work with everything being decentralized except for Set Match Games itself. I
think I have confidence that DAOs will get to the point where DAOs can do that too.
I think this is an example where they might be able to. There are, I think, a lot of other examples people are talking about that might be a little ambitious for where we are right now. But
Yeah,
we're
no,
talking about
totally. Yeah,
games,
yeah,
and it's one of the great things about this scenario is it's very native to all the situations we're talking about. It's all digital things. It has to do a
yep,
lot with numbers already. It has to do with a
yeah,
lot of
yeah,
discrete elements already that can be,
yeah,
that are already
yep,
compartmentalized. Um,
right,
so there are very discrete decisions you can make, like should this be displayed here or not? You know,
right,
and that's a decision that a DAO can definitely make. Whether or not it will
right.
make it wisely is a little trickier, but
And that's
at
right.
least the
That's another
decision
question.
itself is
But yeah,
different.
so that's on our minds.
Yeah, cool. Okay, I think that is nice. Let's see how we're doing here.
But yeah,
We're
squad is
30%.
the like
This is going so slowly.
game marketplace. We're at 30%. Awesome.
Yeah, I feel like maybe I should stop it and start it again. I don't know.
Oh wait, it says compiled. Did it say compiled successfully?
That was in a different window.
Oh, that's another. Okay, I
A
see.
different tab, I should say.
Yeah, that's
Yeah, I don't want to.
a bummer.
Let's see if it'll go quicker.
Yeah.
I mean, it may just get stuck in the same spot again. I don't know. But
Yeah. Oh no, no. Oh, I see. You're scrolling through, and I'm confusing the output.
yeah, sorry. I'm doing confusing things.
Yeah, we're already about to 30. Let's see if it
Let's see if
gets past. Yeah. Come
it's
on.
not looking great. Maybe if we try HC run first. I mean, it'll probably have to just do the exact.
It's gonna have to. It's gonna have to bundle,
Yeah.
and Cargo's gonna have to build it.
Okay. Well,
so
we may have to come back to this.
yeah, yeah. I did run the test, and they all pass.
Yeah.
So
yeah, and then I think that
it would be cool to see them
understanding it. Yeah,
on
it definitely
stream.
would be useful. I can show the to-do app running,
Yeah. Let's take a look at that.
which is sort of fun. I think I maybe need to.
I'm gonna change the screen title here. Um,
I love this HC console it gives you, where the only available command is exit.
is exit. Yeah.
Yeah, you try to put anything else, and it's like
Yep.
available commands are exit.
Yep.
Okay. yeah, I got this to-do app running. Then I realized, why build a to-do app on Holochain exactly? If it's for personal to-do lists, maybe the idea is.
Yeah. No, this is a group to-do list. Yeah, this is a sort of arbitrary. Anybody can make a to-do list.
Right.
I think. Yep.
Something like that, anyway.
And anybody can check them off, and so that's how that linking, that like link thing works. Like anybody in any of the cells, anybody running this DNA can add and complete to-dos.
Yeah, so it would be really cool if we could both run this and then see it communicating, but
Connect to each other.
I'm
Yeah.
not sure if this actually works like that, because
I think that's where you need to set up a production.
Right.
And there's a lot of configuration for this, but setting up a production conductor.
Yeah, I don't think this is on that, because every time I've started this, it's not showing anybody else's lists or anything, so it doesn't seem like it's connecting it. But anyway, here it is. You can create a list.
Cool.
And then you can add items.
It says Holochain connected. I don't know what that means.
I actually think that might be a placeholder. Like if you look in the app, in the UI. Where is it?
Let's
probably. Yeah, the
It's a
connect.
long shot, but let me run it and see if I connect.
Yeah. Like check this out. Import
Yeah.
connect. So it would be this, except
So
I think it's just
it's
I think he's the idea is you would check if it's connected, but I think he's just putting in connected and then saying if connected,
so
put a check
connected.
mark.
Yeah. So that connect and connected are not actually the same there.
Right, that's what I mean. So it's like you can see the idea, but right now it's just always gonna say connected.
The ideas aren't even connected or related. React Redux has a function called connect, which does something sort of
Right, but that's just not
generic,
being
not related to this.
right, but yeah.
There's a data model somewhere
I mean, you can
that
see the
has a
idea
connected
here. It's supposed to say this,
property.
but it's not doing what it looks like it's saying.
No, I think React and Redux are very confusing and like have things in a strange order. So I don't think it's actually. I don't think we know what that is. We would need to look at the connect action
Yeah.
and see what the connect action we're doing, and then what data it was setting connected to, depending on what.
Yeah, maybe. I don't know.
Holochain.
I assumed that because this connected thing is never really defined as
Yeah, so
anything.
down at the bottom here, you see it says, down at the bottom, it says export default connect map state to props connection.
Yeah. And here's
That connect function is from React Redux, and it connects.
Oh, right. Yeah, right. Here we go.
It runs this map state to props function on the, and then puts those properties into the connection component, which is up above, which is what we just saw.
Right. Okay. So I guess we don't really know what.
And then, but it takes that from the state, like the full state, which affected by actions. So there's probably a connect action, and we'd have to look at that to see what it was doing.
Yeah. Well, let's.
Holochain to do Redux.
Yeah. So the to do Redux has the hap in it as well.
Okay.
The one
cool.
we were looking at last time. So.
Gatsby React example. Yeah. Sweet. All right. I'm gonna clone this. And hopefully I can install it quickly enough.
It's pretty small. It certainly took nowhere near this long for me to.
Okay.
Nowhere
cool.
near as long as this other one is taking.
Yeah. Is that still running?
Yep. It's at 30.
Okay.
It's not even back to where it was before. I feel like I'm doing something wrong here, but I don't know what it is. So.
Probably streaming and bundling at the same time.
Yeah, probably.
Okay, so we've got. How did you run this? What were your commands to run this? It was HC.
It's in the
okay.
README for the.
HC.
In one tab you need to run HC run from the main directory, and then in the other one you need to go into UI and do npm install and then npm run or something like that. Npm run develop.
Okay. So we're going into products, Holochain to do Redux UI, and then do, let's see, npm install, npm run develop. Okay. Yep. npm install. So that's now installing over here. Yeah, can you Oh, it looks like, yeah, you responding to that.
That's just me being, I just forgot to change the, I don't think it's, here, I can check this. Oh, interesting.
Yeah, that's evidence that installing and streaming are
I see what it's doing. Weird. That's weird that it's doing that. It's a weird interaction of the terminal with, oh, hey, it passed whatever.
Hey, okay.
It's now going a little quicker. For some reason, OBS isn't good at looking at the different tabs I have open in terminal. So when I go to another tab, it's not going with me. So it was just sticking on the frozen tab. So that's why it looked frozen.
I see.
It was just showing
cool.
that same.
Yeah, it sounds like we're back.
Yeah. So it wasn't ever frozen. It was just showing a tab that wasn't doing anything, and it wasn't switching when I was switching it.
I see. See.
So
all right. Well, this looks like it's going, and it's going to take a while. But
but at least it's actually doing something now.
Yeah. That always makes you feel a little bit more comfortable when you see stuff flying by on the screen. Yeah. All right, so I have node or npm installed, and now I need to npm run develop.
Yeah. If I do that. No.
I'm doing that now. Gatsby develop. And then
I'm just gonna
see if we actually connect
I'll
to
be
each
so
other.
Surprised.
I'll be very surprised.
Yeah, I'll be very surprised.
Yeah,
because I don't think it's as far as I can tell, it hasn't even saved my own local data. Like every time I've run it, it just comes up and there's no lists there.
Yeah, I think that may not relate to it.
Maybe not.
Because I think when you do HC run, you boot up a like development version and just start from scratch every time.
Oh, okay. Yeah, maybe that's all.
So, all right, localhost 8000. Let's see what we got. Chain is running some. Yeah, it says no lists here yet. Create some below. Communicate with Holochain app based on to-do list. Yeah. So right, we're both running our own development, isolated, versions, and we'll have to look at probably the conductor, like the production conductor configuration, to figure out how to do that.
Yeah.
How to get onto the same.
It's possible there's something in here about that in the Holochain to do Redux.
Oh yeah,
code
cool.
Or notes or something. I'm not sure.
Yeah, let's try to figure that out. Let's try to get there.
Yeah, so you can see there are some to-dos in the to-do app.
I see. Yep.
Including share lists, which is not checked off.
I see.
So maybe
it's not only is it not checked off, but it's got
a question mark.
Good. Edit list names, edit list titles. Yeah. So that's cool. The UI.
Right. Yeah, I mean, one question.
Go through.
Oh, sorry. Go ahead.
You're gonna go through the whole.
Oh man, we're having some bandwidth issues. I missed whatever.
Oh, you're cutting out for me.
Yeah, same.
Yeah, I think you don't want to look at bundle JSON because it's just junk.
Yeah.
I mean, this is compiled WebAssembly.
That's the compiled code.
And a tiny little bit of metadata.
Yeah.
Comparatively.
Okay. Well, what were you just saying?
Yeah, let's go through the book and look at the production conductor configuration.
Okay, that sounds good.
Yeah,
So
because
this is what we did
I think
last time.
that is how this app could theoretically communicate with other agents.
Yeah. So this is the stuff that you must have looked at this stuff when you were doing the tests, maybe.
Oh, looks like we need to be watching the chat here.
Oh, what happened?
We're getting responses. So in the conductor config,
Oh,
put that in memory so that you can also set up as file storage to persist to disk. Okay, so there's configurations for this to persist the thing. Puts it in memory. And then there's an example here, container config. Tommel, if you want to look in the chat.
Let's check that out. So this is another. We haven't looked at this repo before, I don't think.
Yeah. But it looks like instance.storage type equals file.
Yeah.
Yeah.
I see that.
And the path is temp storage. So that way, between reboots, you'll get the same thing.
Right.
Thanks, Peter's Grand Adventure. That was very, very helpful.
Yeah. Thanks, Peters.
Looks like Peter's Grand Adventure.
Yeah, right. Yeah.
I love how all of these crypto projects are ending up in places where people are using their gamer tags. I mean, like I sort of became known as Bayesian Agent because that was like the name I had been using on gaming platforms, and in Discord. That's what I was. Right. So all the projects that use Discord know me as that. Oh, it's more of a tag life. Peter's Grand Adventure. That's great. A life tag. Tag life. Life tag.
A life tag. Remember to tag your life, and that way people will be able to find your life easier on the internet.
Are we there at the book?
Oh yes, we can go back to the book.
Yeah, I feel like I just want to like go through that chapter to.
Yeah, so
I'm not like just telling myself probably in the conductor config
over and over and over. Here we go. Should we just go through it?
Yeah, I think so.
Yeah, someone who I'm forgetting their name now because I only ever saw their screen name, but it was somebody in the Holochain chat that mentioned if we continue going through this that they would love feedback on it.
Yeah. So, sounds good.
And we can suggest edits if it's like little things like grammar or whatever. But
yeah.
So they are looking for that. Okay, so yeah, here's the conductor chapter. So to introduce conductors, it's useful to zoom out for a moment to the level of how Holochain runs on devices. That does sound useful. It's designed to be highly platform and system compatible. The core logic runs a DNA instance that was. I don't really want to stop to add like a that there, but if I was doing this on my own, I probably would. That was written in such a way that it could be included into many code bases as a library, thus making it easier to build different implementations on the same platform as well as across platforms. Architecturally, Holochain DNAs are intended to be small composable units that provide bits of distributed data integrity functionality. Thus, most will actually be assemblages of many bridged DNA instances, although I don't think that they've implemented this bridging idea yet. I seem to remember them earlier chapters making a note that wasn't
sure. Yeah.
For this work, we need a distinct layer that orchestrates the data flow, i.e. Zome function call requests and responses between the transport layer, which could be HTTP, WebSockets, Unix domain sockets, etc., and the DNA instances. We call the layer that performs these two crucial functions the conductor, and we've written a conductor API to make it easier to build conductor implementations.
Okay.
So here is what conductors do. Installing, uninstalling, configuring, starting, and stopping instances of DNA.
Mm-hmm.
Exposing APIs to securely make function calls into zones
Mm-hmm.
of specific DNA instances.
Mm-hmm.
Accepting information concerning cryptographic keys and agent information that's used for identity and signing and passing it into Holochain. So they're doing the data validation, it sounds like. Establishing bridging between DNA instances, serving files for web-based user interfaces that connect to these DNA instances over the interfaces.
Sure.
Right. So they do.
So it actually also serves the web server serving your JavaScript files.
Right. So there's a lot. Conductors play quite a few important roles.
Yeah.
It sounds like. Okay, those are the basic functions. In addition, it allows for a configuration of the networking module for Holochain.
Yes, this is what we're looking for here.
Which we'll find out more about. Enables logging, and if you choose to, exposes APIs at a special admin level that allows for dynamic configuration of the conductor while it runs. Okay, and there's a configuration file in Toml, which is what Peter told us about, I think. In regards to Zome APIs, you can implement a diversity of interfaces to perform these function calls, right? Another way is to use language bindings from the Rust-built version of the conductor to build Holochain into an application is to use language bindings from the Rust-built version of the conductor to another language. Some words missing there. That then allows for the direct use of Holochain in that language. So I think that's maybe similar to the way Zomes export their functions.
Perhaps, yeah. I think this is maybe not. I think we can skim this part and be happy to believe that happens that way.
Yeah. Okay, so there are 3 conductor implementations. There's a Node.js implementation.
Yep.
That's using this language bindings thing. There's HCRun, that's what we've been doing. And then there's this funnily formatted thing, Holochain executable. Both of these are...
Yeah,
oh, wait, no,
that's formatted that way because Holochain there is an actual, like, command line executable.
But then they've made this entire thing a link. It just looks funny.
Yeah, yeah.
This is highly configurable. This is a highly configurable, sophisticated conductor for running DNA instances long term.
Right, so it's the production server.
Right, so that's probably what they have people running on those devices that I forget what they're called right at the moment. They were trying to get people to, and I'm sure still are, run little Holochain machines.
Oh, okay.
Long term.
To just sort of participate and
help. I imagine it's just helpful for the whole ecosystem if people are doing that.
Yeah, for sure.
It just because they kind of are hoping for decentralized web hosting, essentially, right?
Right.
And it's helpful if there are a lot of nodes online for that.
Right.
Which, luckily for us, we actually don't have to worry quite as much about that. Or rather, like, as long as people want to play the game, then there will be people that are online. So
at least, depending on how the games are implemented, at least people who want to be looking at games or deciding whether to invest in games, there will be a lot of people online.
Right, or even that, yeah.
Yep.
Which of course is not a given, but
nope.
If we can't get that, then
we're done anyway.
Obviously, the other thing doesn't matter either. Yeah.
Yep.
Okay. It used to be called a container. Now it's called a conductor. Right. So the development conductor is the one you get by doing HCRun.
Okay. Yep.
Then this is the thing you were talking about, where packaging is either -b or -- package.
Right.
if you do
So
this,
you can add a dash dash persist to keep your stuff
right.
between runs.
Package you didn't recall that package is to build. Or run always looks for dealing package file.
Are you reading to yourself?
Yes.
Okay.
I'm just trying to see if we should go through this paragraph.
Yeah, I think I think we covered this in packaging. But we like recall that to package. It builds it in the directory with the suffix. Yeah, hc run dash dash package. So if we haven't packaged it, we hc run won't by default package it. We can make it do that first by adding the dash dash package.
Right. So what is the point of packaging then exactly?
If this is the first time we're doing hc run and we haven't done a hc package yet, it won't have anything to run. If we've made changes that we haven't packaged, hc1 run will be running the old version, the last one we packaged. So I usually will do hc run dash dash package just to get the latest of whatever I built.
Right. Yeah, I guess so. For me, the reason I was able to run the to-do app without doing this package ever was that this repo already had a package in it, I think.
Oh, I see.
Because I never did that. I never packaged anything. I just did hc run, and that must just be because this bundle is already bundled.
It does have bundle.json. Yeah.
Okay, now that makes sense to me. All right. Right. So storage. Oh man. Okay. Storage. This persist thing. So I assume if I did hc run persist with this to-do app, it might save my own local to-do stuff.
I believe so.
Maybe not, but it sort of sounds like that would be what it would do.
No, yeah. By default, none of the data being written to the source chain gets persisted beyond running of the server. This will store, but if we use persist, it'll store data in the same directory as your DNA source code. So
interesting. Okay, well there you go.
Yep.
Okay, interfaces. Dash dash interface. Select a particular JSON RPC interface to serve your DNA instance over. This will expose via a port on your device, a WebSocket, or an HTTP server. It can be used to make function calls to the zones. These are covered in depth in this article. And the default interface is a WebSocket.
Yep.
Okay, that makes sense. Port, so you can specify which port.
Mm-hmm.
Networking, networked. So this is
maybe what we want to try.
Yeah.
Select whether the conductor
try this.
should network with other nodes
that are running instances of the same DNA. By default, it does not occur, and it runs in isolation, only allowing the developer to locally access it. This option requires more configuration. Oh, I see. Is that the next article? Yeah, I think it is. Okay, so let's read on, I think, before we do anything. Okay.
Oh, stopping the server just says exit, and then it's it.
Wait, what?
Nothing. We were at the bet. We were at the end of that already.
Right.
The only thing left was telling us how to exit.
Oh, this the build finished, but something failed. We can look at it later.
Okay.
I think it. Oh, whatever. We'll look
at it. Right. Container is not defined, and that makes sense because. Does it make sense? Don't know. Let's go back to this part of the tree. Come off of this tangent and try it. Let's just try HC test. Oh, that's what we did, isn't it? HC test.
I think so. Yeah, I didn't do that. It looks like it just ran it on its own.
It was building it in order to be able to test it.
Oh, right. Yeah, of course.
So let's try HC test again.
Let me see if this is showing up on stream.
No, you know what? We might need to do npm install first.
Oh,
I think we need to do npm install first.
That would make sense.
Yeah, because it npm hasn't gone out, and the build pulled in all of the Rust packages,
Yeah.
but and it didn't install all of the
Oh.
JavaScript dependencies.
No, that didn't do it. Or, is this not working? No, it says it's up to 8. And it still didn't work.
Huh.
What's an app container loaded instantiate?
Let me see. Let me say if I have things I need to push.
Oh, maybe. Is there a bundle? Maybe we just need to HC package first.
Yeah, let's try that.
Oh, what did I do wrong? Oh, maybe I need to do HC test package. I don't know if that'll work or not. No, it won't.
Yeah, let's see.
Maybe I need to do
No.
this first. I guess HC just package isn't a command.
I think I think HC package.
Should I try this?
I mean, that'll do it.
Well, I tried just HC package. It didn't.
Okay, I see.
It didn't. Yeah, it suggested run package.
Okay.
Oh no. Yeah,
oh, maybe
okay.
it needs to be. Yeah.
That did create the bundle. So there should be a bundle
Okay,
now.
good.
So we should maybe be able to do the test now.
Let's try it now.
Or wait, now we should be able to
No,
do it.
container is still not defined. Yeah. I'm gonna look at
dist bundle.json.
I'm gonna look at my version over here and see if there's stuff I haven't pushed up.
Okay, there is a bundle in here. Yeah, there's a bundle in here. I'm not sure what's going on.
I do have uncommitted changes, but they're just text changes. Clarity, but I will push those up.
Wait, I think I know what's going on.
Run HC test here.
I think I know what's going on.
Okay, cool.
I think I need to do npm install in the test directory.
Ah, yes.
Yeah, so it's like, it's not installing anything.
Oh, okay. Yeah. That makes sense.
It thinks it's up to date, and it didn't have to do anything, so that can't be right. So let's try this, and then maybe it will work.
I believe it will.
Yeah, I think that should solve at least the problem we were seeing before. Okay. All right. Well, let's read on a little bit more while we're waiting. Maybe.
Yep, well, that's going.
Let me make sure the stream is getting this too. Yeah.
Cool.
Right. Okay. So here's the network configuration. HCRun uses mock networking by default and therefore doesn't talk to other nodes. If you want to test multiple nodes, you'll need to install the N3H networking component, which I think I did install when I did it on this machine.
Yeah, I think we both did. Yeah.
If you set N3H path, the environment variable to the path where you installed it. I don't remember where I installed it.
Yeah.
HC1 will automatically default to using real networking.
Okay.
Set the environment variable and start the server by running whatever. Okay, so I guess we need to figure that out. I don't know where I put that.
Yeah, try just like which N3H.
This is done now. Let's test. Let's try this again.
Okay, cool.
Yeah.
Then
we'll do that. Oh, whoops. Now we need to.
Now we have to be in the parent directory, right?
In the real directory. Nuts.
That's very strange.
Yeah, that's surprising to me. I feel like it must be something simple that we're forgetting.
Container is not defined.
I need to build again, maybe?
Let's, will you Yes, actually.
Do what, sir?
I guess we can do this first.
It's done already.
First. No, Peter, we're building on 004 alpha.
Yeah.
Change from container to conductor.
Is this referring to that container though? Is this line?
What's that?
Is this error that this? Is that a JavaScript thing? I don't know. That was my first thought too, but then
so container would be the right syntax. So I'm just making sure that my test here is. Look at index.js.
Right. Yeah. The error we're getting is that it doesn't know what container is, and it says constant app equals container loading.
Right. So it's not called container in 0.4 alpha.
Okay.
It's
so
called conductor.
That is that. Okay. Cool.
So I'm looking at my file here, and I don't have container.
Weird.
Oh, you know what it is? You're in the master branch. You're in the master branch with the default from I had installed with 003, and then had to delete it and redo it from 004 when I started my test file 004 alpha. So if you actually just go into your command line and say git checkout, you won't need to clone it again. Just git checkout the branch name, generic elements. Thanks, Peter. Yeah. Okay, now try HC test.
Yeah, I wonder if I'll need to install again.
We might need to install stuff again, I guess, but. And it looks like there's more stuff to build.
The good news is there's only one more thing here. Or at 112 out of 113.
Yeah.
Okay. I think I need to do the install thing again.
Yeah, couldn't find module Holochain.js. Yeah.
Well, I feel silly now. I saw that container thing when we first ran it, and I just assumed that it was referring to a different container.
Yeah. Yeah, versions are tough, and it's nice to have an expert that knows those differences intimately.
Yeah.
Okay. Looks like that's done. Yeah, here we go.
Now it's doing a thing.
Yeah, there we go.
Cool.
These are passing tests.
There
Those objects is going through, and there's 26 of them.
Yep.
Fantastic. That's
Beautiful. Awesome. Yeah, should we continue with the guide now?
Yeah, actually, let's merge that in masters.
That's what? Sorry.
Anymore. Master is not stable in this video, so
sure.
handled.
I don't see a pull request. Should I make a new one? Oh, Jesse, you there?
Oh, no, but I think you can start a new one, a new pull request, or just new pull request there. Yeah. I don't think we need a lot of conversation here.
Yeah.
The conversation was the stream. Maybe just a note for history's sake.
Generalizing elements Something like that.
Yep, sounds good.
Okay, I'm gonna do it.
Do it.
Cool. And shall I delete the branch, or do you want to keep doing stuff with it?
No, delete branch. Yeah.
Cool.
Sweet.
Beautiful.
And I'm gonna pull those over to my local. Adam.
Right. So how did we do this N3H thing?
Yeah. Let me see. Which N3H? N3H not found. Okay. We probably just followed the literal directions.
Yeah, this is what I remember doing. This npm install npm run bootstrap thing.
Okay.
So I don't know where it is. Where are they saying it is here?
Yeah.
They're saying this folder. I don't know if I have that. Well, let's check. What is it? I don't know if that's gonna be a thing.
If you do ls the squiggly, the tilde, that represents your home folder.
Yeah, but that looks different than that. Doesn't look like a Mac path to me.
No, but /home/Eric, it's an alias for /home/Ezra. Yeah, user's Ezra, which is home in Mac.
I don't have that. I mean, I have.
It doesn't look like that's there. Yeah. Yeah, I don't know how to find that. Maybe we just continue reading and figure this out on our own time without.
Yeah, maybe so.
Spending stream time on it.
We don't have too much time left anyway.
Yeah, we're gonna go till 2 Eastern.
Yeah, 2 Eastern. 3 Central. But,
1 Central.
But I mean, this is findable. You can just do just search for it. We'll find it. It'll take a little while, but it should be in there somewhere.
Starting this. Oh, hey, we've got. I think it's Jakob from Appcast.
Oh yeah. Hey Jakob.
Watching for a while. Struggling to make CoinTalks work. Better leave it for a few days. Yeah, that's totally fine. Yeah, I think we're making good progress here and learning plenty.
Totally.
Yeah.
Thanks for dropping by.
Yeah, for sure.
Nice to see you.
And it'll be great to see CoinToss because that'll be, I mean, any of the games that get developed for this thing are going to need some sort of random initiation.
Right. Yeah.
I guess not Rochambeau, but Rochambeau is going to need similar ideas.
Yeah. Yeah. So we're excited to look at that. But yeah, why don't we finish up by reading a bit more about this networking stuff?
Yeah, let's get through that and then call it a stream.
Yeah. Okay. Let me get this back up. Yeah, there it is. Okay. Right. So this environment variable for N3H, starting a second node. Starting up a second node is a little bit more work. You set the environment variable. Is that the same one?
Bootstrap node. No, it's different. So Bootstrap node is going to be an IP address, right? So Bootstrap node is like you need to know one node that's in the network to get in.
Right. I see. Okay.
So
we're gonna set it
to
the
one up. It'll be on some IP address, and I have to broadcast that to the world of people who want to get in.
Yeah.
And then anybody who's in can broadcast their own to anybody they want to invite, is my understanding.
Copy paste it from the string. Yeah. So you put it. You put the. You have to set it to the IP address from the first.
Look at this. It looks like it's on IPFS. It looks like there's something about
Yeah, the
IPFS
same
in
thing
there.
is, yeah.
That's cool.
Step 2, specify a different agent ID by setting the agent environment variable. But
Okay.
that can just be something simple like this. Okay, cool.
Sure.
Specify a different port than the first node. Okay. And then run all that at once.
Mm-hmm.
that's the port at the end
Yep.
there. Right. So you still do need this variable set, just like the first time.
Yeah.
But now
So if you and I wanted to connect to ours, you would run one, and then you would give me this bootstrap node from yours, and I would run it on mine.
Right.
With that bootstrap node, and I would look up your address, find you, connect to you, and then we would be in a chain, right. on a holochain together, if that's the terminology. But we would be participating in the same distributed hash table.
Yeah. Yeah, so there's no instructions here about the rest of this. Oh, I see. So this variable isn't just the IP address, it's the IP address, and then also sort of an IPFS address, and also TCP. So it's all this stuff.
Yeah, it's all the data that the conductor needs to get in.
Yeah, so it sounds like they're talking to each other over IPFS.
It sounds like they are saving startup information on IPFS.
Okay.
I don't know what it would mean to talk to each other over IPFS, but they're, it might be like, it's probably like the root hash, the hash of the DNA is probably saved on there.
Yeah.
The sort of hash of the Genesis hash is probably saved on there, things like that.
Cool.
That's what I imagine.
Cool. Okay. Well, that makes a lot of sense.
And then we're in lib P2P world, and we're talking to each other.
Yeah. And this is actually, so that's all part of the development conductor thing. The next section is production conductor. So.
Sure. Right. I
wonder how different this is. Right. So this is the one that's targeted at long-term instances.
Yep.
Okay, this conductor will play an important role in making the use of Holochain truly easy for end users because it supports all the functionality that those users are likely to want in terms of managing their Holochain apps or HAPs just on a low level. On that note, a graphical user interface that exposes all the functionality of this conductor to users is under development.
Cool.
Okay, interesting. For now, use of this conductor must happen mostly manually. This conductor is simply a command line tool called Holo. So this is the full word Holochain command line thing.
Yeah.
Its function is to boot a conductor based on a configuration file, and optionally the ability to write changes back to that file. Within that conductor, many DNA instances can be run for one or more agents, multiple types of interfaces to the APIs. UI file bundles can be served, and logs from all of that can be accessed. So this is a lot heavier duty.
Yeah.
First step is installing it. I think we both have done that already, although we probably won't be doing this stuff right now. I'm pretty sure I do have it. I can check. But Holochain.
It looks like I don't, but
version. I do. Yeah, it's in the it's somewhere in that same installation instructions thing.
Cool.
But yeah. Anyway, it's in Rust. It's on GitHub here, so I suppose you can probably install it there if you want to, Jesse.
Yeah. I'll be able to.
I'll get through that. The next article is about it. I guess we can check. So this is I think going to talk about the stuff that Peter explained to us.
Yes.
Maybe not on this page, but to configure it, there's a TOML file. Tom's obvious middle language. Tom Preston Werner, the original founders of GitHub. It makes heavy use of tables and arrays of tables.
Yep.
table is actually a collection of key value pairs. Looks like this.
Yeah, so this looks like it's like
This is just
TOML
talking about TOML.
documentation.
Yeah, talking about TOML. Right. So this is
Yeah,
gonna
let's look
tell
at
us-
Holochain specific stuff.
This is going to tell us what to do with this file particularly. Okay, requires a configuration file to run. Okay, this is just making this command line thing work.
Yep.
So I think we can skip this for right now.
Yeah, so we need to tell the Holochain command where the config file is, basically,
Right.
with the -- config or -c flags.
Interesting. Right. So the implication here is that like if you're using this version of the conductor, you're probably only running one of them,
Right.
or your
I
program
don't
is
know if it's
switching between them all the
suggesting
time.
that necessarily, but you're running it with this config file. You could run two of them with different configs.
Right. I guess it's just funny that
It doesn't make any assumptions about the config you want to run,
Right,
basically, and you have to give it a config file.
Yeah.
It also doesn't make any assumptions about where that config file is.
Right. Okay. Okay. Actually, maybe we don't want to go through all of this right now. If it's
Yeah.
just going to be.
Yeah, this looks like it's getting into like just like
So we can go over it at a super high level, I think. So
at a high level, yeah.
So you can configure agents. So you can make a table of agents, I guess.
And okay, so an agent needs a key file also.
Yeah.
That makes a ton of sense. And then of course a public address, an ID, and a name. Yep.
Right.
And it looks like the ID is not is independent from the public address, which is maybe not completely intuitive to someone coming from regular blockchain world, but
right.
Fine.
Yeah, it does look like it's used in a different way. Okay, next, DNAs. Similar kind of thing. So you can specify different DNAs.
And that's the list of tables syntax there. So we just give it all of the different. We give IDs to and DNA files to all of the different DNAs we want to run.
Right. Instances. This is a configuration of DNA instances, each of which is running a copy of a DNA by a particular agent.
Right. So it's like, here are the DNAs. Here's how to run them.
Right. So again, it has an ID, but then it also has an agent and a DNA.
So it's like mapping. It's mapping agents to DNAs, right? So run this DNA as this person,
as this agent,
and run that DNA as that person. Maybe you want different people. You want to be different agents on different DNAs, whatever.
Right. And then these also have storage, which is
so this is where you can store it in a file, or you can store it in.
Right, and this is the local source chain that we're talking about.
Yeah, or you could store it in memory. I guess that's the storage type, which is memory or file.
Yeah, either memory or file.
Yep.
Interesting. Okay.
Yep.
Next, interfaces.
Right.
Okay. So
this is whether or not the API is listening on a REST endpoint or on a WebSocket. I guess maybe it's not REST, but HTTP. Like what protocol do you use to communicate with this?
Right, and it looks like
there's also an admin interface that you can turn on, which maybe scroll up to read more about what that is.
Right. Yeah.
Whether or not they're admin level functions.
For dynamically administering the conductor via this JSON RPC. It mentioned this earlier.
Okay.
I feel like we would need to read more to understand what that
is
supposed to be for.
Probably things like loading new DNA, things like that.
Right. Like while it's running.
Right.
What is this? Interfaces instances. So we just saw instances. Okay. So this is actually these instances. We're now mapping which of the instances we want to run on which interface.
Gotcha. Yep.
So this is an array of tables, which should provide the ideas of instances to serve over this interface.
Right. Gotcha. Yep.
Although I don't see how this is specifying which interface this instance should be on.
Well, my guess is that it's specifying there's only one, right?
Yeah.
WebSocket interface. Oh, interfaces.driver. They're at the bottom. Type equals WebSocket. So you can give this interfaces.driver multiple IDs and multiple instances. That's what it looks like to me.
Yeah, I guess so.
My guess is 99% of these files are going to look exactly like in this structure. There's going to be one ID under each of those headers, and we're going to choose a type and a port.
Yeah.
And that's going to be that.
Oh, okay. So here's bridges. It's an array of configuration instances that are configured to be able to make calls to Zome functions of another instance. You can think of this as configuring an internal direct interface between DNA instances. There's another section on it.
Okay.
But it's got properties like caller ID, callee ID.
So yeah, I think
handle.
this is having to do with things like new versions, like moving to new versions, maybe. I'm not totally sure.
Yeah, their example here is
for bridging
a HAP store.
Okay, App Store. Right, so the App Store bridges between App 1 and App 2. I see. So does that let App 1 call App 2?
I think so.
Why would an App Store want to do that?
Well, I guess it's like, I don't know.
I guess if the App Store runs both of the apps, I don't know.
Right, if the App Store is giving you access to the DNA, I don't know. It seems different than what we would think of as an App Store, but but maybe
it might be using the term store as in like storage, as in a place for app storage.
This would be really weird.
Rather than a place to buy apps.
It would be really weird to put that in. Maybe if there was no E, but there is an E. Yeah. Storage doesn't have an E there.
I think this all might make more sense if we understood the purpose of bridging more, and that sort of more information thing might make.
On for now.
Yeah, we got 10 minutes left.
Yeah, how many more of these are there? Okay, there's a few more. It would be nice to get to some of these later ones. Logging, networking. Yeah. UI bundles. Configurations of folders containing static assets.
Yep, makes sense.
Served via UI interfaces, which is the next thing. Okay. UI bundles, an ID, and then a root directory.
Makes sense.
Yeah, okay. UI interfaces. It's going to have an ID, a bundle, which is telling it the ID of the UI bundle, I think.
Right. So UI interfaces serve UI bundles. This is like set up a web server for this interface.
Yeah.
Or for this bundle.
Then a port, sure. A DNA interface, which is optional. Oh, a reference to the given ID of a defined interface this UI is allowed to make calls to. Right, that makes sense.
So it's like it's a restriction if you want to put it on there.
Yeah.
So you give it an ID, you tell it what bundle it is, what port it should be on, and what interface it should be speaking.
Right.
Or what interface the DNA is going to expect. Or the instance of the DNA interface. Is it I thought the interface was chosen at some other level besides the DNA.
Yeah, I think that the interface can be running a number of different DNAs,
I see.
and you're
I see.
saying
Yeah,
this
yeah, yeah, yeah.
UI is allowed to call any, into anything that interface is running. I think basically.
Gotcha. So this is allowed to call the WebSocket interface.
Right, and that might have like a bunch of different DNAs and agents
Right.
using it.
Right. Gotcha.
Yeah. Okay. Next, logging. Logger is a table for the configuration of how logging should behave. This seems like it'll be useful for development.
And this is probably where that debug statement that we saw earlier.
Here is a debug
statement. If we get this, if we get this up and running and logging, those debug statements will go to wherever this is.
Yeah. So a bunch of rules.
Mm-hmm.
Okay, right. So this seems like a thing where probably there's no problem with using a lot of standard stuff here, but it will be useful to have it at all, for sure.
Yep.
That seems like something we'll definitely be using. Networking. Networked is a table for the configuration of how networking should behave in the conductor. Currently uses mock networking by default, right? This N3H thing. Bootstrap nodes, array of strings. This is an optional thing, and this is a list of URIs that point to other nodes to Bootstrap. So this is like an address, like a bunch of addresses for you to go connect to.
Right. These are the mirrors. These are the sort of more permanent. Like, we're running these since we're the developers of this system, so we're going to keep these up for you to join.
Yeah.
Others may come and go, but we're sort of claiming that these are going to be pretty consistent.
Yeah. Then the path to the N3H, which we were setting manually in the other.
Yep.
In the other. Here it says the defaults.
Yeah. home/.hc.
Yeah, let's see actually if we have that. Nope. Oh well. Whatever.
Nope. Okay.
We'll find it. Persistence path. Absolute path to the directory that N3H uses to store persisted data.
Okay.
And that's optional. And then one pointing to. That's interesting. Pointing to an N3H process that is already running and not managed by this conductor. This is
so like
the conductor does not spawn N3H itself. So this is like if you were running maybe a few conductors but you wanted them all to use one N3H instance.
Yeah.
Or something like that.
Yep.
That's kind of cool.
Yep.
Okay. And then this is the last thing. Persistence directory. This is a simple key value pair specifying a directory on the device to persist the config file DNAs and UI bundles if changes are made dynamically over. So this is a thing for this admin.
Gotcha. Yeah.
Admin thing. This is only relevant if you're running, an admin interface. Okay. So
cool.
I don't know if I need to talk about
it looks like the admin interface lets you change config files, DNAs, and UI bundles.
Right.
That's pretty
dynamically. I think that's kind of the key thing, because of course anybody could change it when it's not running, but the admin is what lets you change it while it's running.
Yep.
Which makes sense.
Cool.
And then the next section looks like it's about that stuff. It's this JSON RPC thing.
Yeah.
But we're almost out of time, so we should
let's wrap it up
for a moment and talk about what's next. So, what screen should I have up? Maybe Notion or something.
Yeah, let's look at that. Yeah, you have this note at the bottom of Notion. How should we implement curved bonds on Ethereum? How hard would it be to implement them in Holochain? I think in future casts, as people, especially people who are more familiar and deep into Holochain and implementing things on it, especially cryptoeconomics on it,
Yeah.
we might be able to try and get some more information. Like we can imagine that it's possible to do a curved bond on Holochain, but I couldn't begin to start to think about how.
It does seem difficult.
It would be, my guess is that it would be something like what is it, the reciprocal currency kind of thing, the mutual currencies, mutual credit currencies. Um,
Right.
I know those are sort of a Holochain thing, and we could certainly
Yeah, we could
do a
definitely
curve
look
bond with
into
them.
that.
Maybe, I don't know.
I'm actually not even sure. If you did, it might have to be pretty different because
Yeah, I
mean,
imagine so.
the idea of that involves you want the same holochain idea of like you want two agents to be able to do something and then update everybody else later whenever it makes sense for them to do so.
Right.
And curved bonds kind of depend on the idea that like if I buy one, then if
Yeah.
you buy one across on the other side of the earth,
Yeah.
those should be
Global
related.
ordering matters.
Yeah, exactly. And it would be okay for it to be like a little bit out of order, but not very much not drastically.
It might not.
Yeah, because if there was, it's okay for things to be slightly out of order, but not only in terms of the absolute order, not in terms of time. Because if it was like, well, it only takes a minute or two to update, so it's only ever a minute or two off. If you have 10,000 people trying to buy something in that minute, then they're not going to get the price they would.
Yeah, I mean, I guess if you're willing to let the price to deviate from the curve, then ordering doesn't matter. But it matters to the extent that you want the price to match the curve.
Right. I guess actually, yeah. So you could have a system where when you go to the curve bond, it's going to give you whatever price the system, whatever most recently updated global price the system has. And if you're just okay with a system that says that might be like a day out of date,
right?
But we're just going to let everybody buy asynchronously at that price and then update it again once we know how many more people have bought. So
yeah,
you could have a system like that, maybe.
Your returns are going to depend on this deviation too.
Right. Yeah. So the whole thing would have this kind of lag to it. But
I think
not actually make it not
work. My guess is that we'll want to do curve bonds in the environment where all of the curve bond research is happening these days.
Right. Yeah. Because
and like take advantage of the work that's gone into the curve bond.
Yeah, we need to contract. Do that, basically, I mean, we need to do that with DAOs. We need to do that with Holochain.
Yeah, exactly.
We need to do it with exactly. Bonds. So yeah, that's my guess too. But that means we need to start thinking at some point about how does that work for somebody who wants to play a game? Like, do we need to build into Squad a connection to also the Ethereum blockchain, right?
Yes.
So that people can go and buy their components and then then go launch.
Yeah, so we'll need to find a Rust Ethereum client, and we'll need to write our Ethereum contracts to sort of keep track of our Holochain addresses and reference those. So in other words, we'll need Ethereum to be able to return the current price for this address.
Right. Well, I guess probably every Holochain address will also have an Ethereum address.
But we don't want it to have an Ethereum address. We want it to have a curved bond associated with it. So we can. So in other words,
sorry, I thought you were talking about something else. I thought you were talking about I thought you were talking about the curved bonds.
The entry address. So each entry on Holochain has an address.
Yes. Yeah.
And that address, if they're
like an element,
if they're elements, we'll want a curved bond associated with them, and we'll want to be able to look up that curved bond based on having the address.
Right. We'll need to be able to wed a contract on Ethereum to the address of a Holochain entry.
Yes.
And then that curved bond will need to be able to keep track of who owns what, how many tokens or whatever.
Yes.
and those people will also be coming from Holochain a lot of the time onto
Right. So
Ethereum.
we'll need to find a way to map um, Holochain agents
Right.
to Ethereum addresses. So, and we'll probably do that in the Genesis method.
Right. Probably, yeah.
So that basically you have to have in order to join this thing, you have to have an Ethereum address.
Yeah, I think it's worth us talking to some Holochain people to see.
Absolutely.
We should absolutely try to go learn everything about the curve bonds that has already been happening in Ethereum. But I think once we've done that, or as we're doing that, we should also consider how whether or not we could just port all that technique over the Holochain, because it's enough of a challenge to make all these connections that it's going to be fairly difficult either way.
Yeah, no, I think I'm ready to start banging on that. I don't know that it'll be a huge challenge. There's Rust Ethereum clients.
Yeah.
And we just need to make calls with those clients and
yeah. Okay.
I mean, I say just. I mean, it's not. It's not going to be the simplest thing in the world, but it might be simpler than solving curve bonds on Holochain. But you're totally right. We should talk to people who know whether or not that's difficult.
Yeah. Yeah. Well, yeah, I could be overestimating how difficult it sounds to incorporate Ethereum.
But, yeah, I think the next thing I'm going to try to do is start to dig into that and see what it would take.
Right, because that seems like one of the next few things to try to do with the squad.
Yeah.
And then kind of in parallel, I guess we're also trying to start thinking about how you would actually run the actual games and put out the game results.
Right, that's another thing.
And that's sort of what we're doing with the trying to get a working version of that coin toss. Coin toss app.
Yep. And then making those typed game types that people can implement their games as what type. Like a web game would be one type, I imagine. Yeah. A sort of native Holochain game would be another type. A native Windows game would be another type. Sort of pen and paper game might be another. Just like I don't know, just here are the rules, do it, and then tell us what happened.
Right. Yeah. It's right. Yeah. It's funny to. So if you were playing a pen and paper game, the connection to the platform would be largely about game results.
Right. It would be nothing except the text instructions, or even a reference to some text instructions, like go play Monopoly, however you want to. Right. And then it would have to specify a game result format that you would have to then enter correctly.
Yeah.
By hand.
Yeah. Right. Yeah. Okay. So then what should be the direction for this next week or two?
Yeah, I think gosh, I mean, it's like 50-50, right? Like both of those are equally important.
Right, yeah.
And urgent, but I guess the command thing still does technically work. So maybe we try to connect to Ethereum.
Yeah.
And start creating curve bonds and DAOs.
Yeah, that should be. Yeah, well, we'll have to see. I mean, we should reach out to Simon Della, whatever.
De La Rue.
Yeah, we should reach out to some curve bond people, because I'm not actually really aware of any communities or projects that are building curve bond products. Yeah. But I'm definitely aware of a bunch of people that are pretty interested and want to do things with it. So we can reach out to them.
I wonder if Open Zeppelin has done a curve bond contract.
Yeah, that's a good question.
Zeppelin. There's an open issue for one, it looks like. So let's look into this through over the week. And it sounds like next week we'll probably have a um, coin toss, something with coin toss to look at and talk about and go over. And so maybe that's when we can, and maybe Jakob can help us with thinking through the game type implementation stuff too.
Yeah, that sounds good.
While we're talking about how we might use coin toss as one of these set match games.
Right. Yeah, and it would be great if we can get. I mean, ideally, one of the things we would start with would be a couple like extremely stupidly simple games, like a coin toss game or rocks paper scissors, and actually let people start playing with submitting elements.
Yeah, like weighted coin.
Right, just like stupid stuff.
Yeah, that's actually pretty ridiculous, but like perfect for just trying this stuff out.
Just messing around with stuff.
Yeah.
Yeah, that sounds good. So kind of the big project to go towards next is how could we make the connection with Ethereum, i.e. curved bonds and DAOs. Also, I think we should try to, and we can probably just do this on our own time, but try to see if we can get 2 instances of a Holochain app talking to each other using the N3H thing.
Yes, absolutely.
Because that doesn't sound like it would be too hard if we do it the first way we saw it described. And then next week, hopefully, we'll be able to look at the coin toss app with Jakob.
Yep, that'd be great.
Cool. Well, that sounds good.
Very good. Well, thanks everybody for hanging out. This has been excellent. Your help was very very helpful.
Invaluable. Yeah, thanks for checking us out, Peter.
Yep. And we're gonna keep doing this absolutely every week.
Yep. And most weeks you should be able to see our wonderful, charming faces too.
Yes. Yeah. Yeah, and the stream quality is not a priority right now. Getting this stuff done is a priority right now, but we are sort of aware and very slowly making progress on that too.
Right. Yeah. The importance of building a community around this will grow as we have a little bit more.
As we have a thing to build a community around.
The thing. Yeah.
Yep.
Cool.
Let's see. So Peter saw our message in Mattermost. What is Mattermost?
I think that's the Holochain chat.
Oh, I see. Yeah. I think that's our audience right now is people who are really working on Holochain. Yeah, we'll totally post there every week.
Yeah, definitely.
Yep.
So.
Well, cool. Thanks everybody.
All right, y'all.
And we'll do it again.
Sounds good. All right. Stream ending now.
Bang.